cartoon?
Girder.
Location unknown.
Charter 373. This is Commander Mills. My ship was hit by an undocumented asteroid. Send help.
We've crash landed on an uncharted celestial body.
Location unknown.
The atmosphere is breathable. There's something alien out there. You need to be quiet and move.
Well, hello, everybody, and welcome back to Paleontologizing. It's so good to see all of you here today. Happy Monday. It's sort of a new week. And happy World Whale Day. A very happy World Whale Day to everybody. It was actually yesterday, the 3rd February and Sunday. The 3rd Sunday in February. But we didn't stream yesterday. So today is World Whale Day observed. Parentheses. Again, I'm glad you're here. If it's anybody's very first time, allow me to introduce myself real quick. My name is Danny Anduza. I'm a dinosaur paleontologist. So a paleontologist, as I would hope you know already, but maybe you don't, in which case I'll tell you. A paleontologist is a scientist who studies fossils. Paleontologists study the history of life on Earth. It's not just dinosaurs, even though dinosaurs are what I work on. Paleontology is the study of the history of life in general, the past several billion years of the evolution of life on Earth, as we can study it through the fossil record. But dinosaurs are what I work on in particular. I don't know a lot about whales, so this is going to be an interesting stream. But dinosaurs are what I study, what I publish on in the scientific literature, what I talk about with colleagues, what I present on at scientific conferences. Dinosaurs are what I dig up during the summers. So if you are new here, this might be new to you, but yeah, during the summers I go out and dig up dinosaurs, and I live stream it whenever I can. Like, here, hang on a second. You've heard Ceratosaurus? Interesting dinosaur, Dave. I've never heard that. Ceratosaurus? Ceratosaurus?
Oh, yeah?
Yeah. Ceratosaurus.
I wouldn't doubt it. You know, some Brits have said that.
Yeah. And anyway, there's Utah State paleontologist Jim Kirkland right there. I dig with Jim in the fields.
Dinosaurs were the sort of creatures you might think of as inhabiting another planet.
Mr. Delight, thank you for the
or
30
the kind
months.
you dream of in a bad nightmare.
I really appreciate that. Welcome back, and thank you so much for keeping me online for the past 30 months. It's a long time, Mr. Delight. Thank you, thank you.
We're digging in some really important rocks, some stuff that's largely unexplored at the very, very beginning of the Cretaceous period. And holy cow, there goes my router and...
See, anything can happen during a live broadcast.
Oh, man.
Anywho, things are often a bit more predictable here in my office during the off-season. And yeah, today we're going to be talking about whales. Here is the lower jaw of a lovely fossil whale. I'll be talking about this critter. This just came off the printer a little while ago. Printing another whale piece right now. And
Here's some objects. Gorgeous, gargantuan.
Riddler, thank you for the 17 months of
Because
support.
though they died out so long ago,
I appreciate
their
it,
fossil
Riddler.
bones remain.
Thank you,
so
thank
we know
you.
just what they were like and can even sculpt them into still, or rather extinct, life.
Thank you, Riddler.
Paleobirds are dinos. 1 paleobirds
17 months is a
are
long
dinos,
time,
2
and I,
paleobirds are dinos. 3 fish molly.
And I appreciate it.
If you're feeling a bit cheated, try blaming the dinosaur.
And thank you, Hogan, for the 100 bits. I appreciate that too. Thank you, thank you. We got a hype train going here. Beautiful. Yeah, today we're going to be talking about whales in honor of World Whale Day. Whales do have something of a rivalry with dinosaurs, at least in terms of size. We'll be talking about that. Whales also have an incredible fossil history. And whale evolution, the macroevolution of whales, the transition from land-living mammals to fully marine oceanic mammals, it's a really fascinating one.
Scientician. He'll tell you that in
Geek DK, thank you for the follow. Welcome, welcome. So we'll be talking about that history today. We'll be talking about the significance of whales, why they're so important to the understanding of evolution. We'll be talking about why some people have a big problem with whales. People who don't like to accept that living things change over time. Whales are kind of a bugaboo for them. We'll talk about why. And Dolphins SG. Thank you for the follow. Welcome, welcome. It's good to have you here. Again, I'm not an expert in whales. Dinosaurs are what I study. Dinosaurs are what I actually publish on in the scientific literature. There are people who could speak on the fossil history of whales with far greater authority than I. And maybe next year we'll bring somebody on to talk about this. I didn't have enough time to get ready for that this year. But I'll be learning some stuff about fossil whales today, too. And whatever questions you've got, whether they're about dinosaurs, or whether they're about whales, or whether they're about natural history, evolution, extinction, the nature of science in general, whatever you're curious about, I'm here to answer those questions for you. That's the whole point of these streams. So anyway, let me scroll up to the top to say hello to everybody who's here. Top of chat is already gone, but I remember seeing Kodali and Matt M33 and Claire and Taddy Waddy up at the top. We've got Disco Fountain and Claire Burr again. How are you doing, Claire? I hope you had a wonderful weekend. It's good to see you. Little Pink Pony and the Lenina. How are you doing, Lenina? Howdy, howdy. Arlay, good to see you too. I hope your week is off to a good start. Golganek, what's shaking with you, Golganek? Hello, hello. Fall Machine and Neil, the Inimitable One, and Pyro Kitty's Tavern. Aditya Yaukar and Joshua Colossus, Hogan, and Crimson Carnotaurus. Casey Snowart, hope you're doing well, Casey. Bush Doctor and Grim Deviant. Eddie Scarrin and Frozen Yak, Fawn Prophet. And Wombat Hole, Chris TS, and Arid Ecan Wife. Chaotic Time Traveler, hello to you too. Yeah. It's about 15,000 blue whales in the world? That sounds way too high, Aditya. 15,000 sounds like way too high for blue whales. I wanted to say it was just in like the quadruple digits, like a few thousand, but we can look at that. I might be completely wrong. We can look that up. Pablo is on Twitch. Hello, hello. Is that Zygariza? It's not, but good guess. Oh. Blue Jaded. Or is it Blue Javier? Gracias por seguirme, Blue Javier. It's good to have you here. Thanks for the follow. Schedule and the Prusa still up and kicking? Yeah, I've got 2 Prusa printers nowadays. They're real workhorses. Dr. Irrefutable, good to see you too. Mustache Mike, been 3D printing your day weight. Nice. Yeah, farting. Hello to you too. It's good to see you. And Ghostbulb says, hello, did you hear about the whale that swallowed and quickly spit out a kayaker? Not only did I hear about it, I saw the video of it, and it was misrepresented. That whale did not swallow a kayaker. A whale's throat, even a big baleen whale like a humpback whale or a blue whale, the aperture for their throat is like this big or smaller. Like they could choke on a grapefruit. So it didn't swallow the kayaker, even though all of the headlines said that. It just kind of scooped up the kayaker in its mouth. Here. Yeah, I'll show you. Yeah, from CBS News. Whale swallows kayaker and then spits him out off Chilean coast. Whale did not swallow this kayaker.
You gotta see video to our monitors from off the coast of Chile. This is a kayaker meeting a whale, and not in the way you want to meet a whale. A kayaker chomped, in fact, right there in the water by the whale. In fact, he says he thought he was dead after that humpback whale nearly swallowed him. The young man's dad capturing it all on his phone. Here's the moment.
Yep, scooped up.
Well, his dad was saying, stay calm in the moment, like a dad does. Seconds into that humpback whale. Well, the humpback whale stayed calm enough to open its jaws and let the kayaker go. Thank goodness he's okay. He made it back to shore unharmed.
Yep. All of these headlines, swallowed by whale, swallowed by whale. No, that's not what happened, you know? The swallowing implies swallowing. That's not what happened here. But, anyway, here's a video with the guy.
The largest thing you're going to see all morning. Check out this footage. A man
It mouthed the kayaker, sure.
By a whale. Let's show you what happened, and then Molly's going to explain it. But
Look at that.
Yowza.
Truly terrifying experience. You can only imagine. This was off the coast of Chile last Saturday. Father and son casually out kayaking, and then this.
Yeah. Well, not casual kayaking. Ocean kayaking is a serious
It's one of those things. If it was
whale.
not recorded, you would not believe it.
And then I can't believe it was caught on camera, as if.
Although I'm sure the internet will be like, AI.
Yeah. It's like Moby Dick, isn't it?
Absolutely incredible. I mean, how is that dad staying so calm?
I know.
He's saying,
Filming
apparently,
him.
calm down, stay calm.
You'll pop up again. It's not a carnivorous whale. It's fine.
Unbelievable.
He's not going to want to eat you.
All whales are carnivorous, but some of them eat. The animals that they eat are krill, you know? That's the case with this. Looks like a humpback.
A humpback whale just surfacing, swallowing him up, and then releasing him completely unharmed. Absolutely terrifying.
Have we heard from?
That's really cold water, too. So they're down there, you know, water around Chile is not warm. Yeah, I remember reading some quotes from the kayaker. He's like, yeah, I thought maybe I was going to die just from hypothermia. Getting dunked in the water like that. But he was fine.
We have, yes. Actually, we can play a clip of him now after the event. 24-year-old Adrian, this is what he had to say.
I thought it had already eaten me and swallowed me. But of course, I felt that maybe it was a killer whale. We'd been talking about orcas shortly before, so I had that in my head. But when I got out, I understood that, of course, it was probably out of curiosity that the whale had approached me, or maybe to communicate something.
Yeah, anyway. We as human beings are extraordinarily lucky that whales tend to be such gentle animals and so usually disinterested in harming people. Because, oh man, if they wanted to do us harm, you know, stay out of the oceans. Anywho, yeah. But yeah, he got gummed, mouthed pretty good before it spit him out. Exactly, Salamander, yeah. I'm not trying to discount, that must have been absolutely terrifying in that moment, too. I've got a very healthy respect and might even say fear for, like, big things swimming around in the ocean. That is their domain, it is not mine. So I can't even imagine what that would be like. I've gotten spooked before out kayaking and just seeing, like, a bat ray or something go underneath the bow of the kayak. To get grabbed in a whale's mouth, that'd be pretty scary. But it definitely didn't swallow the guy, you know. So yeah. Yeah. And Otter says the whale could have easily drowned him if he or his clothes got stuck. That's true, but I think at the same time, the whale runs the risk of getting its mouth messed up or its throat. You know, the aperture. Here. Yeah. Here, let's take a look at this from the channel What If.
If you've never seen...
Come on. There we go.
Something is lurking in the water. Do you see it?
Yeah, there's two humpback whales. They're doing what we call lunge feeding.
Close calls like this happen with whales more often than you might expect. And although the people in these videos got away relatively unscathed, there's no denying that they were just meters away from being a whale's lunch. But what would happen if they hadn't been so lucky?
We just saw what happened in that
Could a
video.
human body
But, yeah.
survive being swallowed by a whale?
But it couldn't be swallowed.
Has it ever happened before?
Yeah.
This is What If. And here's what would happen if you were swallowed by a whale.
And there you go, Mayor Space. Yeah, that would really... That would probably scare me pretty bad. Getting bumped by a manatee. Just having a big thing in the water next to you. I'm not used to that. You know? It definitely brings up like a prey fear response kind of thing in me. And I think it does for a lot of other
If
people.
you've never seen a whale up close, it's hard to comprehend just how monstrous they can really be.
Monstrous meaning
To put it in
large.
perspective, the blue
meaning
whale is the largest animal on the planet.
And that's a humpback whale they're showing right there. Yeah.
Its tongue alone weighs as much as an elephant, and it can fit anywhere between 400 and 500 people in its mouth.
That's absolute. You're going to hear a lot of statistics like this today when we watch some of these videos that are not super well sourced. But no, you could not fit 500 people in a blue whale's mouth. That's bonkers. That's completely wrong. So, in Santa Cruz, you can see a blue whale skeleton. An actual real-life blue whale skeleton on display outside of the... What is this? The Seymour Marine Life Center, I think it's called? Yeah. You could probably fit... I don't know how many people in there, like, in its mouth. You'd have to get real cozy, but... Like a dozen people, something like that. Not 500. That's nuts. Maybe blended, says the Daslar. Possibly. But yeah, if you could chop up 500 people into dust, yeah, and then compress them into a diamond, sure, you could fit them anywhere. Exactly, Geek. Yeah. Yeah. A protein shake, yeah. And not ironically, appropriately enough, that would be the only kind of way that a blue whale could consume people, too. They've got a small throat.
But we wouldn't have to worry about one of these guys swallowing us anytime soon, because their anatomy makes it nearly impossible.
Does make it impossible.
Instead,
yeah.
We should be more concerned with their smaller cousins, sperm whales. In 1891, reports emerged that a man had been swallowed by one of these whales.
Yeah, I don't think that's true either.
He lived to tell the tale.
So this is way too wide for a sperm whale's lower jaw. They've got incredibly narrow lower jaws. And their mouth doesn't look like this at all. So... Their lower jaw is super, super thin. We actually saw one at the Museum of Natural History in San Diego, at the NAT, as they call it. Let me find that VOD. There we go. Right toward the beginning.
So yeah, we're here in the, I'm not sure what this one is called, but
I don't know, having just gotten here, first visit, I'm impressed with this museum
Skis toward it.
Super cool.
There's a dolphin skeleton.
Yeah. Pretty darn neat. Hand me down from we could move through. You're asking.
There we go.
Anybody tell me what this is right here? It is pretty impressive.
But look at how thin that is. So it's like this
Yes,
wide.
You are correct, Alexander Morrison. Ding, ding, ding. This is the mandibles of a sperm whale right here. They've got these teeth. They don't really use their teeth that much while they're feeding, and so they actually get really worn down as the animal, ages. And it seems like they've kind of de-emphasized their teeth. They also only have teeth on the lower jaw, so the upper jaw of the sperm.
This was the day before TwitchCon, Crimson Carnotaurus. Yes, indeed. Yeah.
But that
Again, look at how thin that is. That lower jaw is like this. And then it slots into an upper jaw. It's also very slim. So what's interesting is they only have teeth on the lower jaw. Their upper jaw just has a series of holes that the teeth slot into. And the upper jaw is just about the same width, at least at the bottom part where it actually contacts the lower jaw. These guys eat soft-bodied prey. They eat a lot of cephalopods and stuff like that, squid. And so they don't need a mouth that's very wide. I think these guys would also probably not be able to swallow a person. I don't think their throat is anywhere big enough for that. And yeah, they basically vacuum feed. They do what we call suction feeding. So they'll kind of slurp up the squid and stuff that they eat, almost like a big piece of pasta or something like that. You know? Yeah. But yeah.
Tail, he would never be the same again.
Yeah, this didn't happen.
According to the story, James Bartley was swallowed when a whale attacked his ship, and he wasn't retrieved until the following day. When the crew found and killed the whale, they quickly brought it on board their ship and cut it open, revealing an unconscious but very alive James Bartley.
Not a chance this actually happened. I call baloney on this. I don't know. You gotta be careful with some of these videos on YouTube, even if they purport to be like science videos. Oftentimes the information in them is not well sourced. Yeah, it doesn't make any sense. Yeah. Anywho, yeah. And better than the alternative, Livia 10 says Calerica. Caleriops. Yeah, we might talk about that critter a little bit today. That is this big predatory raptorial whale. It's enormous teeth. It had teeth on the upper and lower jaws. Pretty impressive, honestly. The teeth on this critter here. Yeah, so we might talk about this animal as well. But first, we had a question about this right here. I have 3D printed on my wall. This actually just finished printing a few hours ago. This is the lower jaw of Coronodon, which is an ancient whale. I don't know a lot about this critter, so let's look it up together. But I was just kind of taken with these teeth. The dentition is so interesting because at the front, you've got these teeth that are evolved for puncturing and holding prey. These are almost conical right here. They're not serrated, they're just for grasping. You know, they're like hooks almost. And then, toward the back of the jaw, you've got these teeth with all these cusps. I look at these and I think they almost kind of remind me of the carnassial teeth in carnivorous mammals. So the teeth that are used for kind of shearing meat and stuff. But these might actually have something more to do with filter feeding. Because whales all evolved from ancestors that had teeth, even the whales today that don't have teeth, the baleen whales. So there's got to be an evolutionary transition in between having proper teeth, with enamel and dentine and everything else, and then having baleen. These cusps on the teeth right here, in some whales, they're like a precursor to baleen. So the whales could almost use these cusps to kind of form a crude filter for flushing out water and keeping prey inside of their mouths. And they just kind of ran with that generation after generation. It became more and more refined until eventually you've got this remarkable baleen. I think there are some whales that might have even had teeth like this and baleen like at the same time during that transition. Again, if I knew more about the fossil history of whales, I'd know this off the top of my head, but I work on dinosaurs. Whales are not my forte. But we'll watch some other videos and do some more reading today, and we'll kind of uncover that together. So, yeah, Coronodon, by the way. Yeah, here we go. This was, oh, and look at those teeth. So cool. Yeah, it's not a particularly big whale. It's about the size of like a smallish beaked whale today. Yeah, and they had, oh man, did they have cool teeth. Here we go. I'm not sure which species we're looking at. Coronodon, Harvensteini, Planifrons, or Newtonorum. But yeah, old friend of mine, Bobby Bozenecker, published on some of these critters, along with some colleagues. 5 new skulls representing 2 new species, Coronodon Planifrons, Coronodon Newtonorum, and young juveniles of Coronodon Harvensteini, first named from a single skull by this team in 2017. Coronodon is one of the most primitive members of the group that includes living baleen whales. So this guy is on the way to evolving baleen. It's on that same part of the whale family tree. So this is a basal mysticete whale, evidently. The name translates to tooth crown, or crown tooth, referring to the large multi-cusped teeth that overlap in the mouth. An ongoing scientific controversy concerns whether these teeth were used for cutting, filter feeding, or a combination of both. Very cool stuff. Here is the actual paper, and it is open access. So here is a link right there. That's weird. It doesn't want to download. Resume. Check internet connection. I don't know why it's doing that. Hang on a second. There we go. Open access paper.
Died, perhaps in some catastrophe. There's no reason to think dinosaurs wouldn't still be here, wouldn't still be dominating the Earth.
And Celtic Hero E, thank you for the follow. Welcome to Paleontologizing. It's good to have you here. Yeah. Here's a publication. First authored by Bobby Bozenecker. Talking about these critters and trying to figure out what's going on with their teeth, too. So this is, I think, maybe one of the same specimens that Bobby actually put online. I think this is from the College of Charleston Museum, where he used to work. But yeah, let's see some of those figures here. Yeah, there we go. Look at that lower jaw. Beautiful. The one that we have looks complete. I wonder if it'll show up in this paper, that same specimen. Check out those teeth. They're so cool looking. They're really fun to look at. They're just very interesting looking, you know? Yeah. So yeah. Plane Shifter says, what does this whale eat? So that's part of the mystery. We were just talking about that. Yeah. Is this the same one? Not quite. But I have this really interesting mix of different dental features like that. Clearly the teeth at the front seem well designed, well evolved, well adapted for holding prey in place. The teeth in the back with those big cusps, those are maybe for filter feeding. So we'll take a look at the discussion here. Long paper, this is very thorough. There we go. Da-da-da. Maybe they don't really talk about the These new specimens and species indicate that Chironodon had a proportionally large head relative to its skeleton, swam in a style much like modern baleen whales, and likely had a flexible chin and joints in the skull that are typically associated with filter feeding. However, Chironodon appears to have lacked baleen. Reconstruction of the evolutionary tree of baleen whales places Chironodon at its earliest branch, and this is key to understanding the transition from feeding with teeth to feeding with baleen. Pretty neat. Yeah. So yeah. And Marika says, is this about the hoofed mammal? Oh, are you referencing what I posted to Blue Sky yesterday? Because it is, actually. And we already kind of gave it away, but yeah, I posted this yesterday. I've been waiting to do this. So this is a hoofed mammal. Evolution is rad. This, ladies and gentlemen, is a cetacean. In fact, I believe this is genus Physeter. I don't know. I've never actually heard it pronounced, but a sperm whale. Lenina says Blue had no idea what that was. Yeah. Cetacean needed, says Rhacodactylus. Let me show you. Sperm whale lower jaw. There you go, right there. The lower jaw of a sperm whale. So this whale is upside down, opening its mouth. The jaw is sticking out of the water. Right there. It is, that's pretty wild, right? Imagine you're, out for a swim or you're in a boat and you see this thing moving past you. What the heck? It's the lower jaw of a sperm whale. And sperm whales are indeed hoofed mammals. Ungulates. Artiodactyl ungulates in particular. Let me show you. On our tree of life. This is something that's not just been confirmed through DNA evidence, but also, I think much more impressively, through the fossil record, too. So whales, dolphins, and porpoises, whales for short, that's group Cetacea right here. They are part of a slightly larger group that also includes hippos. We call this group Whippomorpha. And they, in turn, are part of this clade, which are hoofed mammals, the cloven-hoofed ungulates, these Cetariodactyla. Also just called Artiodactyla, but once we realized that whales belonged in this group, it's like, oh shoot, I guess we'll change the name to make it clear that whales are part of it as well. But, yeah. Pretty neat. The ungulates. Hoofed mammals. Whales are a kind of hoofed mammal, and you might go, well, Danny, whales don't have hoofs. What are you talking about? They evolved from ancestors that did. There we go. So here's you know, an oversimplified but fun kind of walk through this process. You start with earlier critters like Pachycetus and Ambulocetus. We've got fossils of each one of these, by the way, and a whole lot more in between each one. And on to critters like Cuchicetus. It's starting to look a bit more whale-like, right? Let's up our playback speed a bit, shall we? Critters like Dorodon, very recognizable as a whale. But it's still got little hind limbs. You see the little tiny legs right there? Yeah. And a lot of whales still have remnants of their pectoral girdle there in the skeleton. It's still there. Whether you're looking at a right whale, whether you're looking at an orca, killer whale, they've got remnants of the legs or at least the pelvic girdle still there. It's cool stuff. It's really cool stuff. Yeah. So it's neat. Whales were a big mystery for a long time. Like, where did these animals come from? And it's awesome that we finally got an answer on that. And not just a glib, short answer like, oh, well, they evolved from a hoofed mammal. Like, no, there's a grand and beautiful story there, filled with all kinds of incredibly fascinating details. And we're learning more and more about that all the time. The evolution of whales is one of the great dramatic transitions in the history of life on Earth. It's such a neat story. I'm so excited to share that with you today. Before we jump into some of that though, let's go ahead and, goodness, how did I get 26 notifications? Oh, there we go. Thank you, Claire. Let's do a screenshot and do a Blue Sky post here. Let's see if that looks any good. We will announce our liveness on Blue Sky, so people can tune in if they want to. Oh boy, what are you doing, Photoshop? Okay, I think we're okay. No! Scratch discs are full. Please modify scratch disc preferences. What does this mean? It started doing this the other day, and I'm not sure how to get past that, because it just freezes after this. Scratch disk error. Yeah, how do I resolve this, Casey? Darn, I use Photoshop on a daily basis. I can't have this keep happening. This is after I've already restarted several times, too. Need to free up some space on disk. Hard drive's getting full? Kind of, yeah. I need to get a new one, honestly. Let's see if I can do this in, Oh, come on now. I'm gonna go into Task Manager and close Photoshop. I don't see it in my Task Manager though. Hang on a minute, everybody. We'll figure this out. There we go. 5 processes open. End task. That should do it. Let's try Paint, I guess. Will that work? Yeah, okay, good enough. Crop, and let's go ahead and save that. Oh boy, yeah. 5 gigabytes free out of 930 gigabytes on local disk C. Yeah. Oh, hello, Sweetie Pie. How are you doing? There. Yeah. We're celebrating cetaceans for World Whale Day. And only one day late. Yeah. It's a discussion of whale origins, evolution, fossil record. My creationists are so upset about all of it. And why we should be grateful. Join us at twitch.tv/Paleontologizing. Yeah. Cetacean evolution. Fossil record of whales. Why we should be kind to our oceanic neighbors. Yeah. Okay. Screenshot of Twitch stream. With me in my office. With a 3D printed Pteranodon jaw on the wall behind, plus various framed figures, whale fossils, life reconstructions of ancient whales, and more. Okay. Etc. Save, and let's post it.
Hold on to your butts.
Yeah. Good stuff. Yeah. Anywho, Sweetie Pie, how are you doing? It's good to have you here. Thanks for joining us. Here's the link to that post right there. Yeah. How are you doing, Sweetie Pie? Is it time for treats for you already? Is that what's going on? Is that what's going on, Sweetie Pie? What do you think? Yeah. It's a mammal day on stream today. Not just because you're here, Sweetie Pie, but because we're talking about cetaceans. Whales. You're not too distantly related from whales in the grand scheme of things. Yeah. Again, whales are part of... what is it? Paenungulata? And then outside of that is Let's see. Yeah. Mammals always get to present your streams. This is true, Gimflag. I don't think we've had any non-mammals present the stream yet. Whales, dolphins, and porpoises. Then you get Whippomorpha. You throw hippos in there too. And outside of that, you get this clade, which is other hoofed mammals. So I guess you could call this ungulata here, or painungulata. And then you get the pigos and those critters. Oh wait, no, hang on, Artiodactyla. Anyway, yeah. But this clade also includes cats. They're part of this group, which is, here, if we want to get to cats, we'd go to, up here, the odd-toed ungulates, pangolins, and then cat-like carnivorans right there. Feliformia. Yeah. So anyhow. Yeah. Oh, and thank you, Miss Art Rules. Ko-Fi will do. Here, let's get Sweetie Pie some treats here. Oh, Sweetie Pie. Let's make sure you are well fed and happy. Yeah. Here we go. Here we go. Oh, look at all those treats. My goodness, what bounty. Practically do some lunge feeding yourself. Just open that jaw up and engulf them all. Yeah, there we go. Good stuff. Yeah. Excellent. You enjoying those, Sweetie Pie? Yeah. What's going on with your... Hang on. You've got... Your fur's all wet up here. Did you just get flea medication? Did I just get that on my hands? Did Ios or Lordy just put flea medication on you? And then I just got that all over my fingers? Let me go wash my hands. I'll be right back. There we go. That's better. That's better. Yeah, I only licked my hands a little bit, so I think I'll be okay. I don't have fleas now either, says Salamander. I guess so. I guess so, huh, Sweetie Pie? No fleas for me? Oh, I just almost touched it again. Oh boy. That's my bad, lol. It's okay, Lordy. That's okay. You know? It'll be alright. Aw, Sweetie Pie. They're gonna be fine? Yeah. Yeah. Anywho, let's take a look at this right here. Holy cow, Miss Yvette. Thank you so much, Miss Yvette, Miss Art Rules. Thank you for the contribution there on Ko-Fi. I really appreciate it. Thank you very much. I wouldn't want you to have any billing issues with the landlords because I don't have a cat in that cat fight. I appreciate you, Ms. Art Rules. Thank you for your generosity. I really appreciate it. Yeah. Good stuff. And I know Sweetie Pie appreciates it too. Yeah. Yeah. Make sure I pay my rent on time, huh? Yeah. Good stuff. Good stuff. Yeah. You still want some attention, huh? You still want some attention. Oh, yeah. being real careful not to touch your flea medication. I might have to wash my hands again, honestly. But yeah. Good stuff. Good stuff. Good stuff. Oh, there we go. Get the chin scratches. Yeah. There we go. Yeah. Do you want some more treats? Is that what this is about? Did not have enough? Goodness. Well, we can solve that problem. Ho ho ho. Look at that. Wow. Excellent. Yeah. Beautiful. Good stuff, sweetie pie. Cat hair water, yeah, Instafan, it's an issue. It happens. One of the hazards of the job. Consuming a lot of cat hair. Sacrifices must be made, yes. Passive voice. I've heard some cats can fit 400 to 500 treats in their mouths. There you go, Azure Fire, yeah. Yeah, it's true. And sometimes they still leave some on the desk. We'll see if Mini Pie comes up here and wants to eat those. But I suspect she won't. Anywho. Thank you, Ms. Art Rules. I appreciate that. And that reminds me, we also had some items arrive in the mail today off of the Amazon wish list. Which, I don't have a video sting for this yet, but I do want to make more of a fanfare when people send things off the wish list because I always really appreciate it. It's always good stuff. So, here we go. Mail. There we are. We got a delivery. Let me show you. Let's check the mail, shall we? Well. There's our trusty old mailbox here. Let's open it up. And I don't know why VLC Media Player is having such difficulty with this right now. Hang on just a second. Oh, boy. There we go. Let's see what's in here. Well, we've got a box here. Well. A gift for you. Keep on building dinosaur models. From Ashley. Thank you, Ashley. I appreciate this. Let's see what's inside. I go through so much of this for the 3D prints, so I am grateful. Matte clear enamel, so this is like a spray that I put over the top of a painted 3D print. Helps protect the paint job, and it's not too shiny. Shininess can be the enemy in a place like this. So having it be non-reflective, having it be matte is really important. Thank you, Ashley. I appreciate it. That's not all. We've got some super glue too. I swear by this stuff. It is wonderful. Bob Smith Industries Instacure super glue. I went through like 3 or 4 bottles of this building the full-size T-Rex skull. Holy cow. So, again, I really appreciate this. Thank you again, Ashley. Very thoughtful of you. Very thoughtful of you. But that's not all. What else do we have in here? Well.
Glue is cheap.
Check this out. This has been on my wish list for like 3 years now. And our very same Ashley purchased it. Thank you, Ashley. This is about Rudolf Zallinger's Age of Reptiles mural at the Peabody Museum. Sometimes we do a special stream about this in September, on the anniversary of when Rudolf Zallinger started painting.
Him pretty busy regularly, and it was John that time leading the Beatles with a merry little tale entitled "Please, Mr. Postman."
Check it out. So this is I've wanted to have this for a long time, and it's awesome to finally have it here. The Age of Reptiles: The Art and Science of Rudolf Zallinger's Great Mural at Yale. Very, very influential piece of art here. And now I can learn a lot more about it. This is super cool. Yeah. Exciting stuff and beautiful book. This is really well put together. I'm impressed. Very nice. Yeah. And here we've got a fold-out. Holy moly. Look at this. Holy cow. Phenomenal. Oh, man. If I wanted to put this up on my wall, I could. I could get this framed. That's awesome. Thank you, Ashley. I can't wait to read this. And this might become kind of the framework for one of our streams this coming September. So I really appreciate it. And as a bookmark, I will put this in there so I remember that it's from you. Thank you, Ashley. Good stuff. I appreciate it. Yeah, now that's a fold-out, I know, right, Hogan? Yeah. So, let's put our mailbox away for now. Until the next time we get something from a generous viewer. Good stuff. Good stuff. And Hillary Up says, can I ask what are some things you don't think are done enough in paleo art? Oh boy, I think there's often not enough attention paid to landscapes and plants in paleo art. I think sometimes there's too much of a focus on the animals and not enough on what is the landscape that they're inhabiting. Let's see if I can find you a piece that I think kind of bucks this trend. I don't know if it's going to be on here. Shoot. That's one of them. Another thing is just trying to like reconstruct what members of lineages would look like who haven't been found yet. But we can talk about that. Let me try and find this first and see if I have it saved. I don't know if it's going to be in this folder. I don't think it is. Shoot. Oh well. Is a chance that I'm trying to remember where I remember talking about this before and reposting something about it, I think. I'm trying to remember where. want to say it was on here, but I could be completely off about that. Anyway, there's a lovely, lovely, lovely picture of a big diplodocid sauropod. I want to say like a Apatosaurus. They could have called it Brontosaurus, though. And it was in this fern meadow, and you really get the sense looking at that, like it, suddenly these animals just kind of, they make intuitive sense. It's like, oh, this is an animal that's living in this environment with just all of this plant material, and it's just striding across this landscape. And there's just food laid out everywhere before it, all of this ground cover. It was like club mosses and spike mosses and ferns and horsetails, just kind of in this lush growth like that. And it's like, there you go. It's not just, here's this animal, but here's this animal in its environment, and this is how it makes sense. Like some of the best paleo art, it's kind of, in a way, almost transporting you back into this ancient landscape. It's wonderful. Yeah. Plants and plant-like organisms are cool. I agree, Gahabes. Yes, I agree. Yeah. Another thing that I don't feel like gets done nearly enough, and it's honestly kind of shocking to me, is pieces like this, where we're looking at, it's simple. This is work that was done by Bobby Bozenecker, paleontologist, whom we were talking about earlier. He doesn't do a lot of dinosaur stuff, but when he does, it's really good. Trying to think of dinosaurs and other organisms not just as, here they are, but here they are as members of a lineage. Here they are as a product of evolution over time. Making sense of these animals and showing them in sequence like this. So here, this illustrates a hypothesis about some of these dinosaurs. This accompanied the publication of Navajo Ceratops and Terminocavus. I think this is in like 2020 or 2021. But having discovered these critters and described them, Denver Fowler, my old crew chief, and colleagues are able to kind of start making sense of these like Pentaceratops lineage Chasmosaurian ceratopsids in North America. These animals are not magic. Organisms are not magic. They don't just poof into existence. They have to come from somewhere. And at a certain point, once you've got enough of them from a lineage, you can start to actually predict what the in-between ones will look like from certain geological formations that haven't been very well explored yet. Talk about like the Mesa Verde Formation of Wyoming or the Almond Formation of Wyoming. These late Cretaceous formations that have ceratopsids. The ceratopsids haven't been named from there yet. You can make testable predictions about what they'll look like, and that's one of the really cool things that paleo art can do, and it doesn't seem like anybody is doing that. You know? We're finally starting to get enough of these animals and put them in their proper stratigraphic sequence. Know where they came from in time. That you can start to envision what those, to use a much maligned term, what those missing links would look like. You can predict the morphologies of some of these animals. You can use paleo art to do that. And yet, it doesn't seem like anybody's really doing that yet. Anywho, yeah. It's interesting stuff. This is a project that I'd love to do with Denver at some point, just kind of like building on this theme. But we've both got too many things going on right now, so that might be something that happens a few years in the future. But I think predictive paleo art is one of those things that nobody's really talking about yet. But it's an idea that gets me excited, and I'd like to see some paleo artists start to work on this kind of thing. I feel like there's kind of an idea in paleo art that, like, we have to be as conservative as we possibly can be. Anything that we don't have immediate, direct fossil evidence of, if we don't have the fossil in our hand, then we don't want to say this or that. I want to push back against that idea a little bit.
If you're feeling a bit cheated, try blaming the dinosaurs.
And thank you, Erica's Amber's little
was
sticker.
made that because headgear is so common in artiodactyls that there would be fossil camels with headgear, and I think they finally found one.
Interesting, Eric. Interesting. Was there paleo art that made that prediction? Because I'd love to see that. Yeah. Anywho. This only really works with lineages where... Oh, no, shoot. The thing that I was going to say earlier is one of the paleo artists whom I really admire and think is helping push back against that, like, overt conservatism and this kind of thing is Brian Eng. A lot of his work, I think, is really interesting, even if it doesn't land aesthetically for everybody. I think his really speculative stuff can be really thought-provoking. Putting all kinds of soft tissues on dinosaurs, things that, that don't readily fossilize. He's not saying these animals definitely looked like that, but he's saying more, it would make sense if they had this. So let's go wild a little bit. Let's think about dinosaurs as living animals, and let's get a little bit creative. And I really like that. That same kind of adventurous attitude, I think, could also be applied phylogenetically to dinosaurs. In the sense that if we've got enough members of what seems to be an anagenetic lineage, let's predict what the in-between members would look like, I find that sort of thing really interesting, and I'd like to see more of that in paleo art. So, yeah. Calvary Alps, I hope that answers your question. Yeah. And Totally Normal Will says the metamorphosis of Triceratops, you talking about ontogeny? Over its lifetime lends credence to greater caution? Totally Normal Will, the people who published on Triceratops ontogeny, ontogeny, the development of individual organisms over their lifetimes like this.
Ontogeny.
The same people who discovered this and studied it are some of the same people who are...
Ontogeny.
Who are talking about anagenetic lineages in dinosaurs. Yeah, we're all about ontogeny on this channel. That goes hand in hand with the idea of anagenesis. My point is that, here. The default assumption, in some ways I think unscientific assumption, for dinosaurs and dinosaur evolution is often cladogenesis. So, speciation, like anytime you get a new morphology of dinosaur, it's got to be, oh, that's speciation, Looks a little bit different because you had a split that occurred, and there are now two different species, and now you have two lineages evolving side by side. It gets to the point, though, where every single dinosaur specimen that you find, it gets named as a new species, just because it looks a little bit different. But in reality, in nature, there's so many more complex things going on. Well, there's some ontogeny right there. Ms. Art Rules, thank you for the 29 months. I really appreciate it.
Signed poggers.
Thank you, Ms. Art Rules. Appreciate you. Instead of looking at slight differences between two different dinosaur specimens and saying, oh, they must be different species, there must be a cladogenetic event that happened sometime in the past. If you understand that there's a great degree of individual variation, ontogenetic variation, stratigraphic variation, it can almost kind of simplify the picture a bit. Where if you're able to accept a good degree of variation morphologically within a species, then sometimes it seems like it's just this going on. It's just a population evolving over time without splitting. So does that make sense? Yeah. And over time they change. That's evolution, Ice Alan, exactly. Yeah. Yeah. So the people that champion the idea of anagenesis in the fossil record, this idea that the fossil record is more complete than we give it credit for. We just got to go out and find those fossils, and we'll find lots of variation there because animals tend to vary. Variation due to individual variation, stratigraphic variation, animals evolving over time, ontogenetic variation, animals changing over their lifespans, and that adding some noise to the signal too. The people who are really gung-ho about this idea, myself included, were also very gung-ho about the idea of ontogeny. Accepting the idea that, shoot, a lot of animals change a lot throughout their individual lifetimes as they grow and mature. You know, this idea that ontogeny can explain a lot of the...
Ontogeny.
It can explain a lot of the morphological diversity. It doesn't have to be splitting going on into different species. A lot of that variation is just because animals are complicated, you know? So yeah. Yeah. That makes sense, right? Anywho. Yeah. And Steel Horses C says, look at humans, we are the same. Oh, you mean we vary a lot too? Yeah. Yeah. I think you meant we are the same where all humans are the same, but that's the opposite of what you mean, I think, Steel Horses, right? Yeah. So, human beings change a lot. As we grow and mature. Look at the differences in our skulls from baby to adult. If you were a future paleontologist after the extinction of humans, say you're an intelligent descendant of ravens or something, you're digging up all these human fossils, maybe you'd have an argument with your colleagues. Some of them think, oh, the little ones with the big eyes? Clearly a different species. You know, look how much smaller it is. Look how much bigger the eye sockets are. Look how much bigger the brain case is compared to the rest of the skull. These must have been mini super intelligent humans, a different species. There must have been a cladogenic event in the past. They must have split. And you've got two species living side by side. And look, then you've got another one that's kind of in between. Third species. Like, no, that's just ontogeny. Humans change a lot as we grow and mature. And that's reflected in our bones, is reflected in our skulls especially. So yeah. Yeah. So anyway. Yeah. Pierogi says, is there an evolutionary pressure to pick anagenesis over cladogenesis or vice versa? I think in some ways, because the fossil record is often interpreted as being very incomplete, which it is in some ways, but also I think we don't give it enough credit for being pretty complete in a lot of ways. especially at institutions where they don't do a lot of collecting and they don't do a lot of field work, there's a general assumption that if you have two different morphologies, if two fossil skulls look even a little bit different, they have to be different species. Because, well, we only have two skulls. What are the odds that they're from the same species? You need to go out and do a bunch of collecting, collect big sample sizes, actually have a lot of data there so you can start to see the in-betweens. But also, anagenesis versus cladogenesis. I was talking about this with Denver when I was in North Dakota. I was talking about this with Denver Fowler from the Badlands Dinosaur Museum, my old crew chief. This idea, anagenesis, is fragile. And Rhacodactylus, I think maybe you can speak to this a little bit. This is one of these ideas, anagenesis, that's fragile, it's delicate, it's very falsifiable. If your hypothesis is that there's a bunch of, well, like, it's just one population of organisms evolving over time, instead of splitting, then if you find one that's a weird outlier over here and it doesn't match up with the sequence, you neatly falsify that hypothesis. If you find one of these teal guys from the same rock layer as one of these black guys down here, then you could show, oh shoot, these two lived at the same time. The teal guy couldn't have evolved from this guy because they're contemporaneous. They lived at the same time, so that idea would be neatly falsified. Sometimes in science, oftentimes in science, the more falsifiable a hypothesis is, the stronger it is. Because if you keep collecting more and more and more fossils and this pattern doesn't break, then maybe it's true, you know? Whereas cladogenesis is not falsifiable. I know a lot of people are much more comfortable with this idea because it's a lot easier to buy, but the thing is, it's not falsifiable. You can't possibly disprove cladogenesis, because you could have always had a split somewhere in the past, and you'd never be able to tell. There's no silver bullet for shooting this hypothesis and going, bang! You don't work anymore. You just, something that's not falsifiable is kind of not very scientific, you know? You could always come up with a story as to, you know, oh, well, there must have been a splitting event back in the past. We can always make that assumption. It's almost a special pleading or something. This idea of cladogenesis. Like, all morphology is explained by cladogenesis. All evolution only happens during splitting events. There's no way to falsify that idea, you know? Anyway, one of these days we'll go over, maybe I'll bring Denver on for an interview and we'll talk about this. Especially with regard to ceratopsid evolution in the late Cretaceous. He can explain this better than I can, I betcha. So yeah. Yeah. Anyhow. And Hugan, Pegomast. What is Pegomastax? Let's look that up real quick. And then we'll get back to whales. Hugan wants to know, what about the accuracy of Pegomastax depictions? Oh yeah, it's this little heterodontosaur. Yeah. Miniature dinosaur that thrived in South Africa. That's from the same place as Heterodontosaurus. Tiny 1-inch long jaws. Was this critter actually... Yeah, do we actually know that this animal was full grown? Did they do histo on it? I do wonder about that. Because these proportions look very juvenile to me. It's got a huge head compared to the rest of its body. And we do, as far as I know, have some evidence that heterodontosaurs may have done this kind of thing. There was a talk at SVP about a new heterodontosaur from the American Southwest that seems to have maybe had similar proportions. But I do wonder about that. Yeah. There's the paper right there.
You don't need to salute the paleontologist.
Bort Alive, thank you for the follow. Welcome to Paleontologizing. It's good to have you here. Watch out, Mini Pie. Yeah. There's the paper right there. It is open access. Did they do histology on this animal? 2012. Does this talk about? Yeah. Dude. Southern African heterodontosaurid dinosaur Lycorhinus is established as valid, and a new taxon of the same formation is named Pegomastax. Did they do histo though? There. Let's see. Rudidens. Yeah, I don't know. I don't know if we actually know for sure that Pegomastax... It looks very juvenile to me, so I would want to see some evidence that the critter is actually full grown. To be able to tell that this is not just another ontogenetic stage of Heterodontosaurus or another Heterodontosaur. The unusually deep parrot-like shape of the predentary was suggested by Serena to indicate different feeding specializations among different Heterodontosaurids. Okay. How do we know that's not individual variation, though? I guess it is like the business end of the animal. It's involved with feeding, so it's less likely to be an individual variation thing, but yeah. So yeah, I don't really know enough about this critter, Hugin, but it does make me suspicious.
Try blaming the dinosaurs.
I went to an ad break after asking the question, but would monophyletic vs diphyletic be an example of anagenesis vs cladogenesis? Because
kind of, Eric.
The evolution of seals and sea lions was, and still is to a lesser extent, could be an example.
Some of these strange beasts
I'm not sure I know what you
by
mean.
massive plates of bony armor.
And Darth Goof, thank you for the 41 months of support. I really appreciate that. Thank you, thank you. Thank you, Darth Goof, for keeping me online for the past 41 months. It's a long time, and I really appreciate it. Holy cow. Seals and sea lions. So seals and sea lions are two different clades. So we know for a fact that they split. That's why they're different. And that split would have been a cladogenetic event. But we know for sure that they definitely split. That's why they're two different groups nowadays. So...
I didn't know what dinosaurs was all about until these boys come.
Paleo-dance.
Tactical Sponge, thank you for the 50 months. Holy cow. Thank you, Tactical Sponge. I appreciate you. Thank you very much for keeping me online for 50. It's almost a whole year, isn't it? Thank you, Tactical Sponge. I appreciate you. Ossidae. Let's go to the eared seals. Or the earless seals. True seals. Yeah. So, pinnipeds are these critters. Seals, sea lions, and walruses. And then you've got a split pretty early on between the otarids and the phocids. Phocidae and otaridae. And then you got walruses over here too. But so this definitely was a cladogenetic split. Like, this happened about 27 million years ago, this split. When we're talking about anagenesis, like, where did that image go? Here we go. with anagenesis, it becomes kind of squirrely. Like, is it actually a different species at this point than this point? You didn't have a split. And sure, they look different, but it's the same group of organisms over time. Can you really call them different species? Whether or not you actually have a new species here becomes really wishy-washy, subjective. It's a matter of interpretation, really. With cladogenesis, wow, there it is. They are different species, you know? They have split. So, anagenesis would be like what we think we have for Triceratops. Where we think that we've got just one population of Triceratops evolving over time. They get bigger and bigger nose horns as you move through the... I don't know. It's probably like maybe a little bit less than 1 million years of the Hell Creek Formation. The nose horns get bigger and bigger. The brow horns get shorter but more thick and stocky around the base. It doesn't seem like they split into different species. Instead, the differences are through time. They look like this at this point. They look like this a few 100,000 years later. They look like that a few 100,000 years later. It's the same population. You could say it's the same species, just changing over time. Because they haven't split. There's no splitting event into two different species where they start evolving in different directions. It's just one big population slowly changing over time. Or maybe quickly changing over time. The rate is a little difficult to figure out sometimes. But yeah. Yeah. Anywho. And Lapins du Soleil says, can one branch keep the same species name while the other has to take a new species name? That's an excellent question. Lapins, there's not really a hard and fast answer for that. Because that's the thing, the whole Linnaean system of classification.
I think you should enjoy science as much as you can. And you can't enjoy science alone. You have to share it.
Thank you all for keeping me company while I make dinner and discussing my other childhood obsession. There be whales here.
Double Nickel, hey, thank you for your 3 months of support. Yeah, there be whales here. We'll get to the whales in a minute. But this whole like Linnaean classification system really kind of breaks down when Carl von Linné,
But we bit off more than we could chew.
Hergen Bjergen,
Bjergen and their 6 raiders should have taken a smaller bite.
thank you for the raid. Oh, in our... Yes! All right, we've got a whale part printed. Who can tell me what this is? We'll get to that in a little bit, but it's just finished printing right now. Hergen Bjergen, thank you for the raid. How was your stream? I hope it was really good. Welcome to Paleontologizing. We're going to be talking about whales in a couple minutes here. A no talent idiot writes music. Thank you for the follow. If you write music, I'm sure you've got some level of talent. Thanks for following. Welcome, welcome. For anybody who's just joined us, anybody who's new to the channel like you, writes music. My name is Danny Anduza. I'm a dinosaur paleontologist. So I'm a fossil scientist who works on dinosaurs. We're about to discuss whale evolution and the fossil history of whales in honor of World Whale Day in just a few minutes. But first we're kind of talking about the nature of evolution and how we study it and some of the hiccups that occur during that. So we're kind of in the middle of that right now. So when we're talking about the Linnaean classification system, this was devised before we knew about evolution. This whole system was in place before we actually understood how living things work and how they can be descended from one another. So if a species gets named, we have a name for that species of organism. It can become tricky in that living things are not static. They change over time. And so at what point does it become a new species? And if you have a split that occurs, if one species splits into two, does one of them keep the old species name and then you get a new species name for another one? since these things tend to happen relatively slowly, at least from like a human lifetime perspective, these are problems that like we haven't really had to deal with in the modern timescale yet. Like it can take hundreds or thousands of years for species to truly split, and we haven't been doing biology for that long. It's a fairly new science, you know? And so we haven't really had to deal with these problems just yet. So that was an excellent question there. Who was it who asked it? Lapins Duo Soleil, yes. Thank you for asking it. Like, you're hitting on like a real difficult problem in biology. So you should feel proud that you've found an issue that literally, like, it keeps biologists up at night. It's a tricky one. Yeah. Anywho, let's make sure Mini Pie here gets some food. You also have got the flea medication. I'm trying not to touch it. I think Lordy or Ios put that on you. Probably Lordy. So I'm trying not to get that on my fingers because I know it's just. It has to be put here by your shoulder blades so you won't lick it off. I can see why it looks so tasty. I'm trying not to be tempted myself, Mini Pie. Well, let's get you some treats, huh? Yeah. Here we go. Ooh, what's this? What's this, Mini Pie? Wow. Good stuff. There we go. Look at all those for you to eat. And you're probably not going to eat all of them, so let me snatch a couple. Treatos. Yes, indeed, Reiko. Yeah. What did I tell you about licking the cats? You know, Lordy, I try my best. I'm only human, you know? That flea medication you put on them, it looks so tasty. You know, I mean, look at that. Do you see that? I just want to go, but I'm restraining myself. Yeah. Oh, did you get all of them? Oh, there's another one. Look. Look at that. Oh, you can eat it? What? Looks good. There you go. Crunch it up. Get those, yeah, they're dental treats, so she's supposed to chew them. It's supposed to be good for her teeth. There you go. Get those teeth nice and clean. Yeah. Anywho. Yeah. Good stuff, Minnie. You see all my whale ephemera today? All these accoutrements? Look at this lower jaw. Look at the Coronodon jaw. Look at that, Mini Pie. What? How cool is that? She's like, I don't know, I like dinosaurs more. You know, Mini Pie? Fair. Whale of Fernalia. There you go. Salamander, yes. Yeah. And Wright's Music says, I guess it's a balance of how we classify things and what reality is. Like, species are defined by the COX-1 subunit, right? No, we don't actually have... So if we're talking... Are you talking about, like, genetic markers for what constitutes a species and what doesn't? Because there is not a hard and fast rule there. There isn't. You could talk to geneticists like Science Streams here on Twitch. They'll tell you, nope. We don't have a hard and fast rule for what constitutes a species. But why that? We can also say all speciation is a type of a spectrum, but we also need to define it to make concrete statements. Well, that's the thing, is that we like to be able to make concrete statements about things, but for a lot of species that are in the process of speciating, at what point do they become different species? We don't have a good answer for that. Out of all of the different, like, taxonomic rankings that we have, species is the only one that's actually real, and even species can be really wishy-washy. There can be a, like you said, a spectrum there. At what point does it become a different species? It's like a ship of Theseus kind of problem. And at a certain point, we just have to be comfortable with that as scientists. Like, hey, nature is complicated. There's a lot of complexity there. Trying to put it into neat little boxes and have these strong boundaries here and there, you're kind of imposing human foibles on nature, and that's a recipe for false confidence and misunderstanding. So yeah. Rhacodactylus says, we may try to put boundaries on nature for our own ability to understand it, but those boundaries are often very fuzzy. Yes. And in fact, there's often way more fuzzy than boundary with nature. Absolutely. Yeah. Anyway, I hope that makes sense. Yeah. Nature breaks out of those boxes and does its own things, as you can, to a certain extent. Yeah. When we're talking about at the species level, it does that. And in some other places too, but yeah. Anyway, it's World Whale Day today, or rather it was World Whale Day yesterday. So let's get into some whale stuff finally, shall we? Here we go. Excuse me. Trying to find you a decent video on World Whale Day. And I don't know if there were like a well-regarded aquarium or something. We'll look at that video in a bit. But I don't know, I was hoping to see like a news broadcast or something. Oh well, that's okay. Let's just look at this video instead. From Insider Science, talking about whales, how they got so big, and how we know, and why it's important. It would help if the video had sound, huh? Come on, YouTube.
Whales are the biggest animals of all time.
Already, we're 4 seconds in and I've got quibbles with this. Got beef with this. Whales are not the biggest animals of all time. You could say they're the most massive animals of all time. You might be right about that. But they're not the biggest. They're not the longest. They're not the tallest. Those honors go to dinosaurs. Critters like Patagotitan. These great big sauropod dinosaurs, some of which were significantly larger than whales in terms of their length, in terms of their height, in terms of their weight. Because whales don't have weight. They're neutrally buoyant. They live in the ocean. They have mass. But you put them on land, and they don't work anymore. So yeah. Charlie Dragon says, okay, but sauropods don't grow gigantic eating nothing but tiny krill? No, they grew gigantic eating nothing but tiny plants. I mean, they're not even eating animals. Think how much more plant material you have to eat in order to get enough protein to grow this large. Krill are pure protein. Well, not pure protein, but they've got a lot of protein in them. Compare that to, say, ferns or horsetails or club mosses or whatever else these guys were eating. You know? Could a sauropod have swallowed a kayaker? Salamander, good question. Maybe a small kayaker. These are animals that were enormous. You know? Like the skull of one of these dinosaurs. Even though they've got comparatively tiny heads compared to the rest of their body. Yeah, they would have had a bigger throat probably, but still, I don't know if they'd be able to swallow a kayaker. You know? Yeah.
A new dinosaur is coming to the halls of the American Museum of Natural History. This titanosaur is a really huge animal. It's over 120 feet long.
Yeah.
It lived in what's now present-day Argentina about 100 million years ago.
So it's longer. It's about 20 feet longer than the longest blue whale ever recorded.
The last 20 years have really been the new golden age of dinosaur discovery. New kinds of animals have been found all over the world, in Africa, and Asia, and Patagonia. And this is just one of the latest.
Look at that. So there's paleontologist Diego Pol right there, who's not very tall. He's probably about the same height as me. Maybe I'm a little bit taller than him. This is just the thigh bone, just the femur. The left femur of this dinosaur, Patagotitan. That's enormous. That sucker's like 8 feet long. It's huge. And that's just the leg bone. That's just the femur. Nuts.
A couple of years ago, one of my ex-graduate students, Diego Pol, sent me an email saying that a farmer near Galeo in Patagonia had found an amazing dinosaur, one of the largest land animals ever to live. Over the next couple of years, they extracted the specimen from the rocks at the ranch.
Puts it in perspective. Yeah, science streams. I hope you're doing well.
We went down to Argentina, and we...
And Filippo, Dyson Dinosaur, wonderful to see you too. I hope you're having a great day.
3D scanned all the bones in the field and in the lab. We had the whole skeleton completely digitized in 4 weeks.
Nice.
We took the data, and then we carved the bones out of slabs of foam with our 5-axis milling machine.
We'll get to Pachycetus, Anakin Gabriel, you bet.
Carved up, and then we have a complete copy of.
Oh yeah, and shoot, I met Pete at SVP this year. Yeah, he works for Research Casting International, which is a Canadian company that they do some of the best work in the world, reconstructing fossil skeletons.
Skeleton. And from there, we can cast all the elements out of fiberglass. And then the cast gets mounted.
Check that out.
When you're trying to determine the mass, the weight of an animal this big, it's pretty tough. A good example of that is if you pick up a puppy. It's pretty heavy compared to picking up a bird, a chicken that's about the same size. That's because their bones are constructed very differently.
And their bodies are constructed very differently too. Birds have got connected to their bones all of these air sacs, pneumatic diverticula, you know, these air-filled spaces in their bodies. Sauropod dinosaurs would have been much the same. So they would probably be more lightweight than you would imagine, just given their size.
The bones of this titanosaur were, while not hollow, they were what we call cancellous. So they had lots of little tiny air pockets all through them, like a piece of styrofoam. So the bones themselves would be very, very, very light. That's the only way an animal like this could get so big.
Yep. Yeah. And so again, this kind of highlights the difference between a sauropod dinosaur and a whale. You know, whales don't have to worry about that. In fact, they want to have denser bones so that they stay neutrally buoyant in the water. If they're too lightweight, they just bob up to the surface like a cork. But they have to be able to move through the water column at will. So they evolved to be neutrally buoyant, essentially. They evolved to be, in effect, weightless. Sauropod dinosaurs are not like that. They're living life on land. They have to deal with the full force of gravity and all of its consequences. That's why sauropod dinosaurs are heavier than whales. You see what I mean? I only mean that half facetiously. they might have less mass, but again, they're living on land. They're playing by a completely different set of rules, you know? Yeah.
We chose to display this animal now because it represents one of the newest big dinosaurs that's been found anywhere in the world. We have some tremendous things here. We have the blue whale, we have the Tyrannosaurus rex, we have the Barosaurus, and now we're going to have the Titanosaur.
And there you go, Dr. Irrefutable. Yeah. Yeah. And Starmus says, can you imagine the tremors caused by a herd of sauropods passing by? It's cool to imagine that. Like, and I know that's a shorthand for, like, large size. You remember this from Jurassic Park. I mean, like, what a visceral representation of, like, oh, here's a huge animal walking toward you. Wouldn't have been like that in real life. Sorry to burst your bubble, but it would not be like that in real life for a Tyrannosaurus or for a sauropod. Maybe if they're jumping up and down and trying to create big impacts on the ground, then they would do that. But these are animals that were supremely well adapted for life on land. They're not stamping around like this. They're just walking, you know? If they're exerting enough force to shake the ground, they're doing something wrong. So dinosaurs like sauropods or like tyrannosaurs, they had limbs that were, you know, specially adapted for bearing a lot of weight on land. And they would have had things like, you know, like fleshy foot pads that would have helped absorb the impact. So these animals could literally sneak around, you know?
In favor of the predators.
So this is from Prehistoric Planet from a few years back.
Have the largest eyes of any dinosaur, which gives them superb low-light vision.
So instead of like roaring their heads off and running headlong at a prey item, they would sneak up. You know? They had to relearn walking. There you go, make your thumb down.
They're
Sure.
able to move through the forest in near silence.
Yep.
Thanks to cushioned pads on their feet. A group of Edmontosaurs.
Anywho, you get the idea. Yeah. And I've heard very heavy-footed cats. Well, those are domestic cats, right, Kodali? And Charlie's Dragon? Chances are they wouldn't be like that if they're stalking a prey item, too. You know? Most house cats have got it pretty easy, you know? They get food delivered to them in a bowl. They don't really have to worry about catching prey or becoming prey to a predator. They can afford to stomp around a little bit. And they've also been selectively bred. You get all kinds of weird cats.
You don't have time to put dinosaurs in your dinosaur movie.
P. Campos, thank you for the follow. Welcome, welcome. You know, there's all kinds of weirdly bred cats. Cats are... I love them, but man, have people done some bizarre things to them. And in a few generations in the wild, like, a lot of these bizarre traits would become less and less and less common because they're just not advantageous to a cat in the wild. And I would be willing to wager that heavy-footedness, stomping around, it's not a good trait for a cat to have if it wants to survive in the wild, you know? Not when stress talking, but when being annoying. Well, there you go, Condal. You got a cat with a lot of personality. And sometimes cats like to be annoying and to make noise and all that stuff. Yeah. Not as much as dogs. Dogs have been bred to be unrecognizable from wolves, says Maggie LaViolent. That's true. Yeah. For whatever reason, it seems like the dog genome is also just more plastic than the cat genome, too. Like, you know, the two most different breeds of cat are far less different from each other than, you know, a Chihuahua and a Great Dane. These are animals that came from the same ancestor, and they've been specially bred to be wildly different from one another. For whatever reason, the dog genome... And you could talk to Science Streams about this, I bet. Talk to Belint or talk to Lita, and they'd probably be able to tell you about this. There's something unusual about the dog genome. There's something that makes it different from cats. And that you can get these wildly different phenotypes that arise from genotypes that aren't that wildly different. There's like a certain kind of plasticity in their genes that allows you to get these crazy differences. Truth is, thank you for the follow. Welcome to Paleontologizing. It's good to have you here. Yeah. So yeah, Maggie makes a good point here. Yeah. And Scooter MC, thanks for the follow. I appreciate it. Howdy, howdy. Good to have you here. Yeah. But yeah. You don't know where the dinosaurs are. There you go, Hugan, yeah. Yeah. Anyhow. Here, let's get into this. We got, what, 4 seconds into this video? Let's start it from the beginning, and let's get into world whale now.
Whales are the biggest animals of all time.
They're the biggest mammals of all time.
Heavier than elephants.
Well, the longest mammals of all time.
Woolly mammoths. And even dinosaurs.
We talked about how that's not true. Those animals have to live on land. They are heavier than whales are, because whales are weightless.
But they weren't always the titans of the sea.
Yeah.
Let's rewind the clock around 50 million years. No, you won't find any whales here. You have to go ashore.
Yep.
Meet Pakicetus, the very first whale.
And yes, indeed, that is a whale. I'll be going, what? That looks like a wolf, rat, deer thing. And, you know, fair. What about Ambulocetus? Ambulocetus comes after Compsognathorus. Here. Let's take a brief detour and let's meet Pakicetus in another video. Let's go in depth a little bit. We're doing some Inception stuff. We're gonna go one level deeper from this. We're gonna dive deep on Pakicetus here, and then we'll continue the video. And there you go, Scooter MC. Yes, indeed. Here, let's meet that ROUS here. It's not a rodent. It's a hoofed mammal.
Of Natural History in Paris, one of the birthplaces of paleontology.
Yeah.
They have been assembling the skeletons of prehistoric animals for over 200 years.
Yep. We talked the other day about Cuvier and the mosasaur and all that. Cuvier helped establish this museum.
They now have one of the few complete reconstructions
Here we
of
go.
the extraordinary whale ancestor, Pakicetus.
Yeah.
You see it's a quadrupedal animal with forelimb and hind limbs. It means that this animal was definitely partly terrestrial. And obviously it's quite a strange animal, very small. It more looks like a dog with a long snout.
Like a dog?
Pakicetus is one of the strangest surprises of evolution. A whale ancestor that looks like a small wolf with webbed feet for swimming.
The key thing about it is it has elongated
Phil
finger
Gingrich.
and toe.
So we'll see. Remember this face and that name, Phil Gingrich, because we'll see him in another video that we'll be watching when he was a bit younger. See him in a documentary from the 90s.
Toe bones, so clearly it's already semi-aquatic.
Pakicetus was a creature of the shoreline, hunting for fish and perhaps other small animals in the shallows.
And we think that it was using its longer snout to probe for aquatic prey in the water, and so it was feeding in the water, while almost certainly going out on land to breed and have their young.
Once they adapted to life in the shallows, it took 10 million years for the descendants of Pakicetus to become fully aquatic. Why did it take so long?
So long? That doesn't seem like that long to a paleontologist, but okay.
Because to live underwater, they had to change. It is one of the most remarkable stories of total physical transformation in the annals of evolution.
It's so cool. Whales are so cool like this.
After Pakicetus,
beautiful example
whales
of
take about 10 to 12 million years to evolve into fully aquatic forms. And during that time, their hind limbs tend to get smaller, and their skulls tend to get longer. And
so I want to make this very, very clear as we're talking about this. What Mark Ewan is describing, their tails get longer, their hind limbs get smaller. We're not talking about during the lifetimes of these animals. Animals like this, they don't change during their lifetimes. That's not what evolution is. Again, this idea that I think a lot of people have because of things like Pokemon is that, evolution, it's just change over time. So like animals can change over their lifetimes. No, that's not how it works. No, that's not how evolution works at all. What that is ontogeny, creatures changing over their lifetimes. But those changes don't get passed on to their offspring. Evolution is change between generations. So you watching right now, you at home watching this broadcast, you're a little bit different from your parents, who are a little bit different from your grandparents, who are a little bit different from your great-grandparents. Change over the generations. Each generation is a little bit different because everybody's a little bit unique. We are all, in a true sense, special snowflakes. It's true. We are all genetically unique. There are a few different changes in our genetic codes between generations, and those changes can build up over time. And under the right circumstances, natural selection can shape those changes so that those changes happen in a certain direction, maybe. That's what we're talking about here. When we're talking about these dramatic changes over time, this is between different generations. The next generation is a little bit different from their forebears, a little bit different from their parents, from their grandparents, et cetera, et cetera, et cetera. And then those changes add up over time, To
evolve into fully aquatic forms. And during that time, their hind limbs tend to get smaller, and their skulls tend to get longer. And the nares, which is the hole in the skull where the nose is, moves up the skull. In addition, their forelimbs tend to turn into flippers, and they get more vertebrae in their back, which makes their bodies longer.
Yeah. Pretty cool stuff. So yeah, from so terrestrial a beginning here.
Around 50 million years. No, you won't find any whales here.
From so terrestrial a beginning, you get
Meet
whales.
Pakicetus,
Yeah.
the very first whale.
And is it the first whale? in order to be the first whale, it has to be the first member of this clade of Cetacea. And I think there's some debate whether it's actually Pachycetus or whether it's Ambulocetus, whether it's even earlier, whether it's Indohyus. Indohyus is the critter that we have right here in our background today. Indohyus. Indohyus. There we go. Tonight, thank you for the follow. Welcome to Paleontologizing. Yeah. So this critter seems to be on the lineage going to whales. It almost looks like a long-legged rat or something. But it's a hoofed mammal. It's an artiodactyl. It's pretty cool how these things can work, you know? Look at that one with the stripes. Ah, I love it. Very, very Eocene here. Maybe even Paleocene. Kind of deer-like, yeah. In terms of its feet, it's got those like deer hoofs. Those cloven hoofs. It's an even-toed ungulate. So again, it's not just fossil evidence that shows this, but genetic evidence too.
Pumped together in one vast supercontinent.
Nova Penguin. Thank you for the 4 months.
Soon occupied every corner of that world.
Thanks for using that Prime here. I really appreciate it, Nova Penguin. Thank you for keeping me here online. Your support, it means a lot. Thank you. Yeah, whales, dolphins, and porpoises are part of Cetacea, part of Lipomorpha, and that is part of this clade right here, Artiodactyla, the cloven-hoofed ungulates. So hoofed mammals that have got 2 toes, or sometimes 4 toes. It's always an even number, but cloven-hoofed. So that's things like deer, goats, pigs, bison, llamas, giraffes, and hippos. Out of all of the mammals today that still have hoofs, hippos, right here, hippopotamuses, are the closest to the whales. Which kind of makes sense when you think about it, right? I mean, yeah. Yeah. And Maggie says the Hyrax is supposed to be related to the elephant. Yeah, the Hyrax is an Afrothere. So, Afrotheria is this clade here. They're pretty far, actually, from the cloven-hoofed mammals. There we go. Elephants, elephant shrews, and more. So there's the African elephant right there. And the Hyraxes, Hyracoidea, 4 living species. They're the sister group right next door to this group where you get elephants. Yeah. So anyway, mammal phylogeny is really interesting. Partly because mammals just take off after the extinction of the non-bird dinosaurs. When dinosaurs, except for birds, go extinct, mammals just have a field day. They're like, oh boy, we're gonna diversify like crazy and take over all of these ecosystems. It's kind of nuts what they're able to do. Yeah, here's a clip I just logged the other day.
The extinction 65 million years ago left a void.
Now we know it was 66 million years ago, but yeah, fair enough.
With the end of the dinosaurs came a new opportunity. Out of the hole left by the Holocaust came the little mammals.
Yep.
If you want to argue is plausible that mammals got through and dinosaurs didn't because mammals were small and smallness conveys advantages. They weren't small because they knew a mass extinction was coming. Presumably they were small for negative reasons because dinosaurs dominated the environments of large-bodied creatures.
Yeah. Anyway. The mammals that survived the extinction of the dinosaurs did not look like elephants or whales They looked like little things like, well, like this. Little possum-like animals, mouse-like animals, shrew-like animals, vole-like animals. These were critters that were, in some ways, not to overly dramatize things, but they're kind of barely hanging on in a world ruled by dinosaurs. And then, when that asteroid hits, and basically all of the animals on Earth that weighed more than 20 pounds are killed off. Only the small, insignificant, seemingly unimportant animals, those are the ones that survive. Only then did mammals seize the opportunity and evolve from small mousy looking things into cats and horses and bats and whales and giraffes and what else, you know, all the other mammals that we have today. It's pretty lucky for us as human beings that that happened, because if it hadn't, there's no reason to think that we would be around today. If it hadn't been for that asteroid strike 66 million years ago, for that freak accident that changed the course of evolution on Earth, we wouldn't be here today. It's cool to think about, you know? Really makes you realize that what we have going today, we are so lucky. Like, be grateful for every morning that you wake up in your present form. Because, like, things would have been a lot different if it hadn't been for that freak accident, that asteroid strike. We are so incredibly lucky. Didn't have to go this way. In fact, it was a 1 in a billion shot that it went this way, but it did. We're pretty lucky. Yeah. And would dinosaurs still roam the world? Absolutely, RTF for them. Absolutely, yes. There's no reason to think that dinosaurs were really in decline or... Yeah. Where is that clip? Let me find it for you real quick. There's nothing at all inevitable about the rise of humanity. Quite the opposite, honestly. The so-called higher mammals. Yeah. We got lucky.
Or if the discovery of the iridium layer is a real indication that subtle climactic pressures were at work. But one thing is certain. Without extinction, life on Earth would have taken an utterly different course, according to Stephen Jay Gould.
Yeah.
And it's therefore likely that we're here today because, by the luck of the draw, dinosaurs who had been dominant over mammals in ordinary times got felled in a mass extinction.
That's why we're here, you know? Yeah. Toner Bellin says, I heard that dinosaurs and especially pterosaurs were declining in species numbers by the end of the Cretaceous. I think it's true for pterosaurs, but is it true for dinosaurs as well? I don't think it's true for dinosaurs. I think a lot of that is sample bias. Here. Part of that is that sometimes researchers will compare the Maastrichtian and Campanian stages of the late Cretaceous and go, well, there's so many more dinosaur species in the Campanian than in the Maastrichtian. So, like, dinosaur species are going down over time. But I think what a lot of people fail to realize is that the Campanian is so much longer than the Maastrichtian. Like, of course you're going to have more dinosaur species over time in the Campanian, because it's like twice as long. Also, a lot of the work that we've done in the Maastrichtian, people like Jack Horner, Denver Fowler, Museum of the Rockies. We've managed to synonymize a good number of the dinosaurs at the end of the Cretaceous, for instance, in, like, say, the Hell Creek Formation. So, yeah.
Again, real easy to say that Tyrannosaurus ontogeny included Nanotyrannus, and therefore we could take out another dinosaur. So, when it comes down to our end Cretaceous, we have 7 left. And that's a good number. I mean, that's a good number to go extinct, I think.
I suspect that a lot of this, if you were to apply the same ideas and run the same tests, do the same work, do histology, figure out who's young and who's old and who's actually the same species, a lot of your dinosaurs in the Dinosaur Park Formation, in the, these other, like, Campanian dinosaur formations, it would be the same story. I think dinosaurs are oversplit in a lot of, like, Campanian faunas. It's just the Hell Creek has been so intensely studied that we've been able to knock down this list to just a few dinosaurs living at the same time. I think that's probably also true for a lot of these other formations as well. And that's one of the reasons why people say, oh, well, dinosaurs were in decline right before the asteroid. No, it's just because we've managed to figure out the dinosaurs right before the asteroid and get rid of a lot of that like false diversity. Diversity that's not actually taxonomic diversity, but only morphological diversity. It's the same species looking different in different growth stages. I think there's an awful lot of that work still to be done earlier in the age of dinosaurs. So it doesn't look like there's a decline.
If you're feeling a bit cheap,
does that make sense?
Try blaming the dinosaurs.
And Wombat Hole.
Explosives in a beached whale sets timer.
Oh no, Wombat Hole, that's not a good idea. We could talk about that too, but yeah. Anywho, yeah. So yeah, at least not every theropod is automatically a megalosaur anymore. There you go, Tone Rebellion, yeah. Tony, going back to Stephen Jay Gould here.
And it's therefore likely that we're here today because, by the luck of the draw, dinosaurs who had been dominant over mammals in ordinary times got felled in a mass extinction for which no creature could prevail or prepare. No, some I didn't say that. Got killed in a mass.
This is bad editing here. They should have just cut that part out where he misspoke because he didn't mean to do that. But they're like, oh, Gould, every word is precious. No, cut that part out.
Extinction for which no creature could possibly prepare. And again, that gives
I didn't know what dinosaurs was all about until these boys come.
Thank you, Executive
Don't get
Storm.
to watch much, but still here, let's keep it going.
Hey, I appreciate you so much, Executive Storm. Thank you for the 54 months. There's a reason you got one of those founder badges there, Executive Storm. Thank you for holding on to that. Thank you for continuing to support the stream. I appreciate you tremendously. Even if you don't get a chance to watch much, know that your support means a great deal to me and to the other people watching. You're helping support science outreach on Twitch, and I really appreciate it.
For which no creature could possibly prepare. And again, that gives the history of life its very quirky, fortuitous, chancy character. We are literally here only because of the good fortune of dinosaur extinction.
Yep. We've got no reason to think that there wouldn't still be dinosaurs running around today if it weren't for that extinction event. If it hadn't been for that freak accident, that 1 in a billion shot of an asteroid hitting in exactly the right place at exactly the right time. Think about it this way. Going back to our time chart here. Here's us today in the black pixels at the very top of the Cenozoic era. The Pleistocene, the Holocene epoch is so short it doesn't even register here. It's within those black pixels at the top. That's where we live right now. The Cenozoic era, the age of the mammals, goes back 66 million years. This is 66 million years right here, this yellow block. 66 million. Right here, between the blue and the yellow, right there is where the asteroid hit. The blue is the age of the dinosaurs, the Mesozoic, and it is so much longer than the age of the mammals. Even the Cretaceous period is longer than the entire Cenozoic era. It's longer than the entire age of the mammals. A period should not be longer than an era, but that's how it works. Eras are supposed to be super long and encompass multiple periods. To have a period that's longer than an entire era is... it's kind of nuts, but there it is. That's how it works. So, dinosaurs first evolved out here, about 240 million years ago, give or take. Dinosaurs continue to diversify and become more and more successful until the end of the Triassic. Then an extinction occurs. Big biotic crisis on planet Earth. A bunch of species go extinct. Dinosaurs take over the Earth at the beginning of the Jurassic, and they hold on to it all throughout the Jurassic period. There may have been another asteroid impact at the end of the Jurassic that caused the extinction of multiple dinosaur groups. But it doesn't kill the dinosaurs entirely. They continue on through the Cretaceous. They continue to rule the world for the entire Cretaceous period. And only when that asteroid hits the end of the Cretaceous do all of the dinosaurs go extinct, except for a handful of birds. Birds are dinosaurs. And those birds really kind of took off after that too. They diversify into... excuse me, a crazy diversity of species. How many species of birds do we have around today?
Over 9,000!
Yeah, that's quite a few. Dinosaurs still outnumber mammal species like 2 to 1. Birds are more speciose than mammals. There are more bird species. Twice as many bird species as there are mammal species. You could make an argument we're still in the age of dinosaurs, but I don't know. I think it might be a little needlessly pedantic. But anyway, yeah. The irony of birds taking off. There you go, Cobraven, yeah. But yeah. Anywho. Oh, thank you, Claire, for posting that. What is this? Jim talking about this?
What we're working in right now, these rocks are from the earliest Cretaceous period. Would you call this like a recovery fauna?
There's, what, 6 kinds of diplodocid in the Morrison?
Yeah.
The whole group is gone. It doesn't occur in the early Cretaceous anywhere. All these big predators. You know, we have this diverse, large predator guild.
Yeah.
Yeah.
Allosaurs, ceratosaurs,
boom, you cut it down
corvosaurs.
to like 1 or 2 big ones at a time in the Cretaceous. Completely different ecosystem.
Yeah.
After that, you know, what did it? It's the top of the food chain that gets wiped out, which is, you know, during crisis, they're the ones that are going to get hit harder.
Sure.
Yeah.
Yeah.
Wiped off the map, and that's, they were very successful in Morrison. You know, it's, you know.
So what Jim is talking about here is, in the Morrison Formation, you've got at least 3 really big theropod groups. And we know these are different dinosaurs because they're from totally different families. In the middle there, you've got Allosaurus, and they're all over the place. Super common. And then a little bit more rare, you've got Ceratosaurus at the top, and then Torvosaurus, much more rare down below. But here, at the same time, in the same place, you've got 3 huge theropod dinosaurs. Different families. And then it could be all 3 of them go extinct, or it could be just the top and the bottom ones. Ceratosaurus and Torvosaurus go extinct. Maybe Allosaurs actually have direct descendants in the early Cretaceous. We don't really know. But like, out of all these dinosaurs in the Morrison Formation at the end of the Jurassic, almost all of them die out. They're all going strong until the end of the Jurassic, and then, bow, something happens. And almost all of these guys disappear, except for maybe Camptosaurus and Gargoylosaurus there. Maybe Mimorapelta, another ankylosaur. But like almost all the rest of these guys disappear without a trace. And they're replaced by other dinosaurs. Maybe that migrated in from other continents. But something happened there. Something happened there.
I really do think that, they were killed off. It's a pretty rapid turnover, of a very diverse fauna. But it really is nuts. We lose the Morrison fauna. Jurassic Park goes extinct.
What we're...
Yeah. Good stuff. Anyway. So all of that, we're talking about macroevolutionary trends. We're talking about the history of life on Earth. We're talking about extinction and how that kind of changes the course of life on Earth. In one way, that's what opens up this avenue for whales. The reason why whales evolve in the way that they did is because you had these other animals that ruled the seas during the Cretaceous, things like mosasaurs, things that were, like practically whale-sized, these giant marine lizards that ruled the oceans during the late Cretaceous. And prior to that, you had giant plesiosaurs, short-necked and long-necked plesiosaurs. But these are animals that they ruled the waves during the age of the dinosaurs. They're not dinosaurs, but these guys in particular, mosasaurs, are kind of lizard. Kind of like a giant Komodo dragon with flippers. That's a good way to think of these animals. And then when the asteroid hits, these guys are wiped out by that. No more mosasaurs, no more plesiosaurs. They're gone. Even a bunch of shark species go extinct. In fact, I think it's like the majority of shark species die out when that asteroid hits. And so suddenly, thank you, Lady Fiend.
The wingspan of this flying monster would have been about 15.5 meters.
I hope you didn't open my gifts yet.
Lady Fiend, did you send the spray paint and the Rudolph Salinger dinosaur mural book? I opened those at the beginning of the stream. Thank you so much, Lady Fiend. I really appreciate that. I made a big deal out of it earlier. You can go back and look at the VOD. But thank you very much for sending these. That was very generous of you. I really appreciate it. I did a whole thing with this mailbox over here and with the "Wait a Minute, Mr. Postman" song and all that. Trying to make a bigger deal out of these wish list things. Thank you for that. Appreciate you. Thank you, Lady Fiend. Take a look at the VOD. It's all in there. Anywho, what was I saying? Oh, well, when that asteroid hits and these giant marine predators go extinct, when the mosasaurs are no more, suddenly there's an opportunity for mammals to take over. And it's free real estate. It's free real estate. That's kind of what sets the stage for whales to evolve. Let's get back into this.
Life on Earth spent millions of years clawing its way out of the oceans. But whales took all that effort and threw it out the window.
Well, because it's free real estate. Suddenly, those big predators in the oceans, they're gone. It's free real estate, you know? So they go back in.
50 to 40 million years ago, they traded in their forelegs for flippers.
And Izzy Black says, do the mammals and the marine reptiles live at the same time? No. Well, whales and marine reptiles, like we're talking about, did not live at the same time. So when the marine reptiles like mosasaurs had their heyday, mammals mostly looked like, mostly looked like this. Just little possum-y, weaselly, mousy, voly, shrewy little critters living on land, doing their thing. It was only after the extinction of the dinosaurs that mammals really had a shot to get big, you know? Because suddenly those slots are open. Suddenly there's room. Suddenly there's it's free real estate. Suddenly it's free real estate, you know? Yeah. Does that make sense? So that's what sets the stage for the
50 to
whales.
40 million years ago, they traded in their forelegs for flippers. In fact, some whales today still have leftover bones of hind legs. Once submerged, their weight under gravity no longer mattered, so they could theoretically grow to enormous proportions.
And they did. That's why I say whales are not bigger than dinosaurs. They're playing under different rules. You know, whales cheat.
And they did. Today, a blue whale is 10,000 times more massive than the Pakicetus was. But this transformation wasn't as gradual as you might think. In fact, over the next 37 million years or so, whales grew increasingly diverse, but their size remained small.
And that story is not quite as clear as it used to be. There were some whales that got bigger than we had imagined earlier on. Things like Parucetus, but even that critter has been downsized recently.
For example, one of the first whales with baleen instead of teeth was only 18 feet long, making them easy prey for predators like giant sharks.
Demon Prince says, is there a survival strategy that seems to be most successful across all mass extinction events? Like, for example, were aquatic animals more likely to survive than subterranean living animals if we consider all known mass extinctions? No. That's the thing, is that different mechanisms that cause big extinction events like this, what somebody like Kevin Payton would call biotic crises. Because that's the thing, is like mass extinction is not really like one thing. When we say the big 5 mass extinction events, that's an oversimplification in a lot of ways. A mass extinction event is not like one thing. There's lots of different causes. Here. Big 5 mass extinctions. So, yeah, the big 5 mass extinctions in Earth history. Yeah, the end Ordovician, the end Permian, late Devonian, end Triassic, end Cretaceous. These are often considered the big 5, but some of these are actually, I don't know, there's a lot of other, like, extinction pulses that happen in Earth history. And some of these, like the end Ordovician, I think this is actually a 2-pulse extinction. So this shouldn't be one big peak. There should be 2 that are about half the size. One after the other with, like, a gap in between. The late Devonian extinction, there's, like, there's debate as to how severe this actually was. You can also see that some of these take a lot longer, like the late Devonian extinction, as opposed to the end Ordovician extinction. So it should be 2. Anyway, like, mass extinction event is not a discrete thing where we can point to it and go, oh yeah, that's a natural phenomenon that happens. It's like, no, we're talking about a lot of different events with different causes, different timescales, different severities, and we just kind of call them mass extinctions, even when we might be comparing apples and oranges. So is there like a strategy that organisms can take to avoid all of these? No. And some of these, the marine extinctions, like all of the critters that go extinct in the oceans, sometimes that's more severe than the extinction events on land. Sometimes it's less severe. Sometimes it's all of the big critters that go extinct, and the small critters tend to, on average, survive a bit better. Sometimes it's the opposite. Sometimes it's an extinction, like a bunch of extinctions happen because of changing Earth climate. Well, they really all kind of have to do with Earth climate to certain extents. But sometimes it's really slow, like the release of greenhouse gases by volcanoes, like with the end of the Permian, it seems like. Permian mass extinction. Sometimes it's an asteroid strike, like at the end of the Cretaceous. Maybe at the end of the Jurassic, which that kind of shows up here. A bunch of groups go extinct at the end of the Jurassic, so that's a spike there. But at what point do you call it a mass extinction? You know? What's the threshold for that? We don't have a good answer, and that's why I think I agree with Kevin Padian about this. The term mass extinction is much more loosey-goosey than we would like to admit. There's a lot more complexity there, you know?
Girder.
Oh, yeah. Yeah. Murph says, be a generalist? But in what sense? You know? Generalist in terms of what you eat? Because if you're a generalist over ontogeny throughout your lifespan, eating different things at different times, that might make you more vulnerable to extinction. Or maybe less vulnerable to extinction, you know, based on what are the current conditions. Like the big point is, like Stephen Jay Gould says, I think, so much of it comes down to luck, you know? When the going gets tough, sometimes the tough all die out. And it's just the little squishy micro guys who survive. Sometimes it's the big critters who die out and the small critters who survive. Sometimes it's the opposite. You know, it's tricky. Yeah. Oops Kaput says, what did the little mammals that survived eat? Not much. Yeah. But here's the thing, Oops Kapoots, is that even among mammals, I really hope this gets published soon. It's a wonderful figure. But this shows the extinction rates for different groups at the end of the Cretaceous period. 100% of the non-bird dinosaurs died out, 92% of lizards and snakes, 94% of birds, 90% of the mammal species. 90% of the mammal species. Oh, wrong button. Sorry. There we go. 90% of mammals at the species level died out at the end of the Cretaceous. So we've got this story that like, oh, well, you know, the big dinosaurs died out and the little mammals survived. It's like, nope, the little mammals also almost went completely extinct. Out of all of the species we have of them from the latest Cretaceous, 90% of them don't seem to make it across the KPG boundary into the Cenozoic era. 90% of them die out. So yeah. Yeah. Murph says crocs, turtles, and amphibians did pretty well. It might be... Well, yeah, those were critters that, you know, the crocs and champsosaurs, the salamanders and newts, the turtles, only about 20% of their species, maybe like a quarter of their species died out. their extinction rates are probably a little bit higher because if there were rare species that rarely fossilize, we're less likely to have them in the first place, I guess. So these extinction rates might be slightly higher than we realize right now, too. Like, this percentage could go up significantly if we just discover a couple more turtle species in the Cretaceous. And then we don't have them in the Paleocene. Like, oh, shoot. We've just discovered new turtles that completely die out, you know? But anyway, it seems like the critters that do relatively well are the critters that live kind of in swampy areas. These are critters that, even when the rest of the world is on fire, stuff in the swamp is still doing okay for the most part. Like, times got tough, but, you know, there were a lot of dead animals, a lot of nutrients that, you know, even when the world is completely ablaze above the swamp, there's still organic matter falling down into the swamp. And that food chain in the swamp is still doing okay. Swamps tend to not catch fire, says Echidna. In a lot of cases, yeah. Yeah. And so Shrek survived the extinction. I'm not sure Shrek was real, Bahasmanzer. But, yeah. I don't know. What does Shrek eat? I don't know. Probably like sludge, slime, gross stuff. That's kind of his thing, right? Earwax. There was probably some kind of product tie-in at some point too. There was probably an ad campaign where Shrek ate Arby's or something, or Burger King. That's the thing, is that when the world is on fire, there's no Arby's or Burger King, so Shrek probably would have gone extinct too. Yeah. Turnips, slugs. Ogres eat onions. Thank you, Major Tom Tom. Yeah. Yeah. I don't know. Was there a product tie-in? Shrek fast food. Okay, yeah, Twinkies. I think Twinkies are well known for surviving apocalyptic events. Oh, but here, McDonald's. I don't know if this would... Yeah. I think the supply chain of McDonald's would be severely disrupted if there were to be an asteroid impact. So I think Shrek maybe might die out. I don't know. I'm not sure. Yeah. But yeah. No, you sure about that? Pretty sure greasy cardboard will still be around, says Regadaclus, maybe. Yeah. Bovids being large mammals would make it hard to keep going. True, Dinosaur Dave. Yeah. Bovids, you know, being made into fast food. Hamburgers made from bovids. Yeah. Yeah.
At least.
Yeah, I don't know. Different foods made from different mammals. Yeah.
Hey, Lisa, if you don't want lamb chops, there's lots of other things I can make. Chicken breast, rump roast, hot dogs.
No, I can't. I can't eat.
Hot dogs. You know, maybe hot dogs would be a good option. You know? Yeah.
Hot dogs.
Yeah. No. Skeptical Tardigrade. Hey, thank you for the follow.
Wreaking his prehistoric fury on modern man and his puny machines.
I appreciate the follow, Skeptical Tardigrade. It's great to have you here. We love water bears around here, as do many of the folks who stream science on Twitch, and the skepticism is an added bonus. I appreciate you. Welcome. Here, let's get back to whales, shall we? Here.
Years ago, that an ice age tipped the scales in the whale's favour. Ocean temperatures and currents shifted, sparking concentrated swarms of plankton and plankton-seeking krill. It was an all-you-can-eat buffet for the baleen whales, who grew larger as a result.
So yeah, the super large size of baleen whales is a recent development that only happened in the last few million years. And that might be because of kind of a global ice house kind of regime when you've got these ice caps at the poles and everything.
And the larger they became, the farther they could travel in search of more food to grow even more.
Yep.
You can
Kind of a
probably
feedback
see
loop.
where this is going. 3 million years later, humpbacks, for example, have one of the longest migrations of any mammal on Earth, traveling over 5,000 miles each year. As a result, modern whales are the largest they've ever been in history. Take the biggest of the bunch, the blue whale. It weighs more than a Boeing 757, has a belly button the size...
I mean, does it really, though? That plane has to contend with gravity, and the whale doesn't. The whale's in water. The plane could be a lot heavier if it were a boat, you know? But,
size of a plate. And its network of blood vessels, if you laid them out in a line, could stretch from Pluto to the sun and back.
yeah, I don't buy that for a second. I'm sorry. That's literally millions of miles. There's no way that the blood vessels of a whale extend millions of miles. I call baloney on that. That is not true. Maybe a few miles, sure. I'm willing to give you that. You know, a mile is 5,280 feet. Multiply that by several million? Not a chance. If you were to take every cell of a blue whale and line them up end to end, that wouldn't be several million miles. I don't buy it.
Over 2.5 times. In fact,
Pluto's average distance to the sun is 3.7 billion miles, says Isolated. Yeah. Not a shot that that's the case. Yeah.
the largest blue whales are so huge that scientists think they may have hit a physical limit.
Yeah, and Nick Pinson actually talks about this in his book, I think, Spying on Whales, which I would highly recommend. Good book. You can also get it as an audiobook. He's a paleontologist who studies whales. But yeah, there's something about like when they open their mouths and then they have to close them in order to be able to do this gulp feeding that they do. There's a... Here. Blue whale lunge feeding is what it's called. Yeah, take a look at this. Here, we can play some of our music over it because there's no audio. Blue whale feeding on a massive krill. So look, you've got the whale swimming at it normally with its top side at the top, its right side up here, and it's able to somehow detect this cloud of krill over here. Whether it's through echolocation or smell or sight, I don't actually know how they locate it. Here we go. The whale approaches this giant mass of krill and then tilts over sideways. This is nuts. And look at that! Just the whole thing engulfed like this. Nuts. And there, it's gone. All those krill. Yeah, so when approaching the krill, the whales speed up to about 6.7 miles per hour. That's faster than they would be normally. By opening their mouth causes it to slow down significantly. There's a lot of drag there, a hydrodynamic drag. So this is how these whales are able to get so big, is through this kind of lunge feeding. When you've got a huge baleen whale like Baleonaptor, like a blue whale, yeah. So there's an idea that they might be kind of hitting their heads up on kind of a ceiling for maximum size for an animal like this.
When they open their wide mouths to feed, they engulf enough water to fill a large living room, so it can take as long as 10 seconds to close them again. Scientists estimate once a whale is 110 feet long, it can't close its mouth fast enough before prey escapes. So it's possible we're living among...
So that might be like an upper physical limit. And I've always wondered about this, like, isn't there, again and again, every time we try and imagine, like, what is the physical limit for an animal to do this or that? If there is selective pressure in that direction to become more extreme, usually there's some sort of adaptation that critters evolve in order to push past that limit that we think is a real limit, you know? It's like Daniel Dennett said many times, like, evolution is cleverer than you are. Which evolution is not like, it's not a thinking thing. It's just, this is a process that happens over time. There's natural selection that occurs that causes new adaptations to develop, and then they get kind of like refined further and further across multiple generations. But this is why engineers often study living organisms and fossil organisms too, is because sometimes these natural processes have come up with solutions to engineering problems that, like, human beings have not been clever enough to come up with. There's been millions of years of development that goes into some of these things, and, you know, our human engineers oftentimes, like, we haven't had millions of years to deal with this. We're usually not clever enough to come up with this stuff. These natural processes over these successive generations, they will solve these problems sometimes. So I do wonder whether, you know, if there were to be some sort of a change in the environment that would cause increased selective pressure on whales to grow larger, whether they could grow larger, whether there would be some kind of new adaptation, a new mutation that arises and then gets selected for via natural selection in order to make whales even larger. Just saying, oh, well, they're this big, so that means that's as big as they can possibly get. Who says? You know? I don't know.
It's the largest animal that will ever exist. Lucky for us, they mostly just eat krill.
Yeah.
This was made in large part thanks to Nick Pineson.
There you go.
Information in his new book, Spying on Whales.
Yeah. Excellent book, which I would highly recommend. On World Whale Day, +1. It's O-N, right? Poyenson. Spying on Whales. Here, he gave a book talk about that. Here he is giving a talk about it here.
Whales have captured our imagination for millennia, and sometimes that fascination with them manifests in very strange ways. In the 1970s, when NASA created the Voyager space missions to send spacecraft on a tour of the solar system and on its way outward, it affixed these golden discs to the side. And on these golden discs were messages meant to someone, something, should that entity want to know who sent these spacecraft on their voyage.
Yep.
And what's really interesting is...
Isn't this a Star Trek thing, too? Isn't this partly where, wasn't this partial inspiration for Star Trek IV, Revenge of the Whales? Yeah. Yeah.
These records contain audio, images, and greetings in 55 human languages, and one non-human language, which is humpback whale song. Now that should be really strange. That's a funny thing.
Demon Prince says, rather say evolution is the most inefficient process observable? It's like, here's the problem, let's brute force it. In hindsight, it seems smart, but considering all the variations evolution went through, it's quite inefficient. Would you agree? Most, if not all, systems are like that. Well, no, it would be really inefficient if you didn't have the driving force of natural selection, but that does tend to winnow down things so that if you had to somehow start from scratch every generation, it would be infinitely more inefficient. But the fact that you're, I don't know, when you've got a lineage of organisms that's evolving, you're already starting off at each generation at a really good point, you know? So it's extraordinarily efficient in a way. I would say in some ways it's much more efficient than like a lot of the like large language model AI stuff that like people do nowadays, because it uses far less energy, you know, than something like that. Does that make sense? Yeah, I don't know. In so many ways. And thank you, Baja Spencer.
Motor of substantial change in evolution. If extinction didn't occur,
I appreciate the prime
group
there.
would dominate and it would last forever.
Thank you, Baja Spencer, for the 9 months of support. I really appreciate it. Thank you kindly. Yeah. Yeah, I don't know. Efficiency is a fickle thing.
225 million years ago,
Rabid Weenus.
beginning of the Mesozoic era.
Thank you for the 35 months of support. I really appreciate that, Rabid Weenus. Thank you, thank you.
If you're feeling a bit cheated, try blaming the dinosaurs.
And thank you, Hogan, for the 100 bits. We got another hype train coming here. Thank you, Hogan, for doing it. I'm sure we get hype trains when we get some support. I appreciate it. Here, let me pull up a video with, with Daniel Dennett with this clip.
Dinosaurs were the sort of creatures you might think of as inhabiting another planet, or the kind you dream of in a bad nightmare.
Thank you, Blockman's Mustard, for the 30 months. I appreciate you, Blockman's Mustard. Thank you. Good stuff.
It's squat completely flat. The
and
bone
Marika.
wall is so thin, it's about the same dimension as the wall of a dirter. A dirter is one of those things you get at the end of the paper towels, the cardboard thing in the middle, you go dir in it. Well, that's what this thing is like.
Noises.
How did you know it was going to be that alert? Marika.
No other creature in the world looks like a half-plucked turkey and walks like a dirter.
And thank you, Oops Kapoots, for the 19 months of support. I really appreciate that. Thank you. Thank you. Good stuff. Here, let's go back to... Was it here or was it the other one? I think it was day 1 we looked at that. There we go. Yeah, here we are. Let's find that pterosaur bone one. Show transcripts. And let's search for Kevin. I'll show you that clip with the pterosaur wing bone.
So, dinosaurs became extinct because they no longer knew how to love each other. Is that correct?
Exactly. And I certainly wouldn't want our species to end the same way.
Hey, crew.
Thanks for everything, Danny.
Thank you for the 8 months of support. I really appreciate it. Thanks for keeping me here online, K Crew.
The exhibit.
Good stuff. Here, it must be in this episode here, our lab tour. Come on now. There we go. The pterosaur wing right there. This is kind of a running joke on the channel. There was an old Paleo World episode where there was a clip of Kevin Padian talking about the thinness of pterosaur bones, and he goes, the
the thickness of these bones, it's a lot like the thickness of a dirter. A dirter is one of those paper towel tubes that you blow through and you go dur dur dur. And so it's just like a wonderful soundbite from that. But it's really true. I mean, look at that. Just incredibly thin.
It's not even potato chip thin.
A dirter.
It's like it's thinner than that.
Wild. Yeah. It
Nuts.
really is like
Nuts.
a dirter. Yeah.
And that long
Wayfield thin. Yeah, there you go, Kennedy. It's just a Wayfield thin
in the
means.
sandbox for a while, just thinking about how do we cradle this. This is not going to be any standard method, but eventually we thought of something that works.
Nice.
I don't like
nuts.
And this is, we're quite fortunate with this site that often pterosaur bones are completely crushed flat.
Yeah.
And here, there's crushing, but there's just enough three-dimensionality that you can add enough glue and with careful prep get out both sides, which is not always possible.
So I can see that my 50,000 a year has been well spent.
Axeman.
Almost a year sub to the best channel on Twitch.
Thank you, Axeman. 18 months. That is almost a year. And at tier 3, holy moly, do I appreciate that. Axeman, thank you, thank you. Good stuff. Holy cow. Yeah. Yeah. But yeah. And Demon Prince, so here's the thing, is that there's no direction to evolution, and that's kind of what I was trying to find with this clip. Is it
in the bacteria, and then you had this.
Is it here? Look at the transcript. There we go. So this is kind of philosopher of science Daniel Dennett talking about this.
Because in many fields, intelligent designers are exploiting the truth of Orgel's second rule that evolution is cleverer than you are. Genetic algorithms, deep learning, evolutionary architecture, nanotechnology, breeding nanotechnology by making novel proteins in an evolutionary setting, machine learning. These are technologies which produce wonderful epistemological competences without comprehension. Watson beats Ken Jennings in Jeopardy. Google Translate. Lovely example of competence without comprehension.
And same with, large language models like AI, even though a lot of those are much more clunky and extraordinarily inefficient, especially with I don't know. That's why DeepSeek was such a shot across the bow. To, what is it, OpenAI? Massively overvalued AI company in the US. There's a bubble there. Not financial advice, just, oh boy. Is there trouble on the horizon there? But the point is, it kind of, I don't know, Demon Prince, you said every path being explored would mean even mediocre solutions that temporarily solve the problem have validity, which is something we actually see even right now. That is how evolution works, yeah. Is that there's no foresight in it. It's just what works best at this moment. What works a little bit better at this moment, rather. That's the thing that tends to prevail. And then if conditions change, it might move in another direction. But that kind of filter of natural selection tends to slowly optimize in the right direction for things, unless the direction changes and then it moves in another direction. You know what I mean? Yeah. Let's get back to Nick Pinson with Secret Life of Whales.
Now that should be really strange. That's a funny thing. it presumes a lot about what we think whales are saying. But the fact of the matter is we still don't know what whale song actually means. We don't know if that's really a greeting or if it's just a comment about what they ate for lunch. And that's a microcosm of this enigma, this mystery of wanting to know where they came from
There
and
you go,
where
Reiko.
they're
Yeah,
going.
good point.
So when you think about whales, you probably have this image in your head. This is a shot of a humpback whale in Antarctica, Wilhelmina Bay. This is more typically what you imagine when you think of a whale, living 99% of its life away from us underwater.
Mr. Harrell.
Bits for a train ticket. I'm mostly into the ICS topics than the ologies, but it's great to see science getting live on Twitch.
ICS topics and ologies? I'm not sure I understand, Mr. Harrell, but thank you for the 200 bits. I appreciate you. Thanks for being here.
Water. They
Thank you
remain
for your support.
inaccessible. So the ways that we want to know about them require tools of investigation that
And Murray Ferret. Thanks for that follow. Good stuff. Appreciate you.
get us there, that extend our senses. 30 seconds after this picture was taken, I took this one from the boat on top of the water, where that whale then came to the surface to go look at the observers observing it. And so this is a bit of that connection.
Physics, mathematics, ICS. I still don't think oh, you mean like the simple sciences, things that are kind of toward the bottom of the funnel, where you've got the fewest variables. Yeah. Oh, they all end in ICS. Oh, gotcha, Mr. Harrell. Yeah. Well, mathematics I wouldn't call I guess I called it a science there. It's not really a science. It's more of like a framework or a language. But yeah. I mean, it's cool. Those things, in a lot of ways, they form the basis for more complex sciences that have got added levels of complexity on top, in the same way that, like, chemistry can be thought of as applied physics, and biology can be thought of as applied chemistry, and then paleontology can be thought of as applied biology and also applied geology. So you just got more and more and more levels of complexity. You've got more and more variables in there. You've got increasingly complex systems that you've got to think about when you're thinking about these larger processes. But yeah. Anyway, Regadactylus says mathematics is formally a logical language and logic is the purview of philosophy. Mathematics is properly a humanity. That's interesting. Or a humanities. I think of the word humanities as being plural, but I'm just being pedantic. But yeah. Anyway, interesting stuff. Let's continue.
Connection that we have to this very enigmatic species where we want to know more about it, but we can't actually interrogate it directly. So this is why the questions that scientists ask
no worries, Reiko,
are some of the best ones for understanding what these animals are all about. Because they're fantastic, because they're amazing, because their traits are so spectacular, our curiosity leads us to ask more and more questions about them. I'm a paleontologist and I work at the Smithsonian, which houses the world's largest museum complex on the planet.
The world's largest museum complex on the planet. How many times a day do you think I vocalize redundancies like that? Probably quite a few.
56 million objects, specimens.
Yeah. Anyway, excellent book by Nick Feinstein. That's why I'm showing you this video here.
Because they're kind of like the vaults of past worlds. If we want to know what the lost worlds of the past were like, whether it's in geologic history or human history, we need that evidence. And there's no better place to find that evidence, to safeguard it, to study it, to take care of it for the future than museums.
That's why we always say,
that belongs in a museum.
That's the whole reason a museum exists, is to safeguard these specimens, to allow for continuity so that we can actually test hypotheses long into the future using the same specimens, using the same objects. Maybe applying new methodologies to old specimens. That's why in many of the natural sciences, museums are the reason why we can do science. It's the reason why we have the possibility of being able to repeat things. Repeatability being one of the cornerstones of good science. That's not possible without museums and without funding for museums, you know? So yeah. But yeah. Brachydactylus says, I just like to point out that because people like to rag on humanities disciplines by making up things like underwater basket weaving. I thought underwater basket weaving was that was a hard science, Reiko, because that requires a lot of complex engineering at great depths and pressures. Isn't underwater basket weaving that's an engineering thing, right? If you want to weave together a basket in the Marianas Trench, you know, that requires input from a multitude of different fields, and it requires great expense. Got to solve a lot of engineering problems, you know? It always throws me for a loop when you make a joke, says Reiko. Yeah. No, the same thing that bugs you bugs me, too. I don't know. I live here in the San Francisco Bay Area, you know? Silicon Valley is just over that way, south of it's the South Bay, you know, Fremont down into San Jose and then up into like San Mateo in that area. There's so much, shall we say, frustrating naivete and just general obliviousness from a lot of people in Silicon Valley. People who think that because they're good at programming that automatically makes them a genius or makes it so that they know anything at all about anything else. And it's sometimes from people in this milieu that you get a kind of scoffing at humanities, the idea of art or literature or philosophy, these things that form sometimes the underpinnings of other fields. The humanities, like you said. I've heard other people in other communities refer to this as being STEM-brained, which I just kind of go, ugh, like, I'm in a science field. I'm a paleontologist. I'm literally a scientist, and I don't want to be associated with the people who think that technology can solve every human problem without any thought at all to human nature, the depths of human experience. I don't know. It's a thing that I think about all the time living here in the Bay Area and kind of just being ensconced in this. You see a lot of kind of tech foolishness. There was that guy the other day who said something like, what was it? Here. There we go. Ugh. Yeah. Silicon Valley built the modern world. Why shouldn't we run it? Oh boy. Just the incredible naivete there. It's just Dunning-Kruger turned up to 11. It's nuts, you know? Yeah. And this is how you get tens of billions of dollars being absolutely lit on fire to do things like Facebook, Meta's, what did they even call it? The metaverse thing? These are the people who want to rule the world, and they completely out of touch just to the point where I don't know, you just surround yourself with yes men, and you create these things that nobody wants, nobody asked for. It's a complete and utter failure, and yet they just keep pursuing it. I'm at a loss for words, you know? Yeah. I don't know. Otter Do It says, I'm one of those programmers, and I agree with you. The amount of overconfident arrogance in my field is overwhelming, and it shouldn't be that way. I don't want to have to think this way about the tech sector, but when it's, I don't know, when you get way too much money pumped into it, you create these people who have just lost touch with their humanity. When it all becomes about pursuing capital, it's like you completely lose perspective, and the whole thing just becomes a cancer. It's growth for the sake of growth, and then even thinking about the stuff that makes us human. The reason why somebody would want to use a particular product, or what is it used, what is the good for society? You know, those kinds of questions, the kinds of questions that fields like the humanities are asking. It's like, well, we can't think that way. You know, it's not good for the bottom line, or it's irrelevant. Like, I'm at a loss for words. We'll continue here, because I'm spinning my wheels at this point. And there you go, Rakidactylus, yeah. And Kennedy makes a good point. Some of the world's best scientists were artists, actors, writers, communicators, human beings. Yeah. Yeah. I don't know. And thank you, Salamander, for reposting that from Gravity. Today, I'm here as a translator. I will finally finish proper translations to your poster. What would be a good day to post it or send it to you? Email it to me whenever's convenient for you, Gravity. Thank you so much. You did not have to do that, and I really, really appreciate it. Size of the file was a challenge, yeah. But I did it! I'm proud of it. Tomorrow will be the last polish, and it will be ready. Thank you so much, Gravity. I really appreciate you. Thank you. Yeah. Anyway, let's get back to whales here. Here, maybe we'll continue with this for a minute. I'll give you the link to this talk, and then we'll get into a documentary about the evolution of whales, something from the 90s, which will allow us to branch off in different directions, and should be some good tangents that come out of it.
And so the evidence of the past that I encounter, the bones of long extinct whales, are right there before me. But I want to share a bit more about how we know about that and what that tells us about where they came from and where they're going. The first most amazing fact about whales is that they once lived on land. Some 50 million years ago, they had 4 legs. They had long, probably furry snouts, nostrils halfway down, not right above their eyes. And over the course of about 10 million years, relatively short period of time, they then start to look somewhat more like the whales that we recognize today, living underwater full time, having a tail fluke, probably doing something that looks pretty fearsome.
There's Leviathan right there, which somebody in the chat mentioned earlier. This, like, enormous, probably super, super deadly odontocete whale, just ravenous. The teeth on this critter are nuts.
And we have this image of this evolutionary transformation as being somewhat one-directional, like it's happening in a linear fashion.
But it wasn't like that.
Actually, that's not really how evolution works. It's really...
So I'm really glad that we're watching this before we jump into another video. And we just talked about this on Thursday, didn't we? But yeah.
Convenient when we look at it
Wednesday,
from our perspective as one stage going to another in a long series of successes. But actually, the way Darwin articulated it here, is evolution is a bushy tree, is actually way more accurate. Evolution is a story of failures with very few successes.
Even that's kind of putting it too strong, almost. what is a success? How long does it have to survive and thrive in order to be a success? Where do you draw the line?
When I look at the fossil record, I'm mainly looking at the story of failures. And the successes, that's where it gets really interesting, because that tells you how things are working today. And so instead of thinking about the evolution of whales as one sort of long succession leading to a successful dominance, this bushy tree of whales, if we went back 50 million years ago, the beach party would look something like this. And
I think I recognize Ambulocetus here, Indohyus. Is this Cuchicetus there? Myocetus and maybe Rhodocetus?
all these different forms went extinct, except for the one in the back that begat all the whales that we see today. The most likely unsuccessful.
And I mean, did it go... I don't know, this kind of gets into the nature of extinction, too. It's like... Were all of these actually offshoots that didn't leave descendants? I don't know if that's the case, you know?
One in the back that begat all the whales that we see today. The most likely unsuccessful one at the time was the one that became adapted to the water full time. So the fossil record tells us about past states that we wouldn't otherwise know. But the fossil record is actually very incomplete. All those artistic reconstructions that I showed you are just that. The actual evidence we can sometimes hold in our hands.
There you go, Dr. Hubs, yeah.
Bits of bone, shards of teeth.
Yeah, and these teeth look a lot like the ones in Coronodon right here that I have in my background today. And, salamander, what is it? Wow! Featherless emu chick. I should bookmark this for a later time when we're talking about non-avian dinosaurs or ornithomimosaurs and stuff, but yeah. Yeah. Anyway. Yeah. Little emus. Good stuff. Good stuff. Let's get to it.
That is the direct evidence of the past. And from that, we have to become good detectives, ask good questions. And sometimes we get lucky. And getting lucky is largely a matter of science in a social context. And geopolitics drives a lot of the expeditionary science that I do. This is a picture of fossil field work in the Atacama Desert of Chile a few years ago, right along the side of the Pan American Highway.
And so a lot of this is described, in fact, this fossil site in particular is described in depth in Nick Pineson's book, Spying on Whales. I'll give you a link to this video, and I'll try and give you a link to that book. I'm trying to stay on the topic of whales here. Holy cow, you can get this good condition for less than $5 US on Thrift Books. It's also available as an audiobook. I'd recommend this one. It's also read by the author, which is really cool. So Nick Pineson actually narrates it. It's an issue sometimes with science books when you're listening to them in an audio format, is sometimes they'll have like a professional reader read them, and then they get half the words wrong. They mispronounce things left and right. And for most people, it probably doesn't really make that much of a difference, but it can really kind of ruin your immersion if you happen to know a thing or two about the subject matter, and you realize when they're mispronouncing words, it really kind of takes you out of it sometimes. That's not the case with this. So if you get the audiobook, I think it's on Audible, or you can get it here. Nick Pineson reads it himself, so pronunciations are correct, and they're good. So yeah. Anywho, Spying on Whales, excellent book, and that talk that I linked to there is Nick Pineson did kind of like as the book launch kind of a deal, I think. But anyway, from there, let's jump to an old episode of Paleo World. So this first premiered in 1994, season 1 of Paleo World. A lot has changed since then. We'll be talking about that. But this is their whales episode, third episode in the whole series. Take a look.
50 million years ago, a hungry wolf-like creature found the sea more inviting than the land.
It's an oversimplification, but okay.
As schools of fish swam by, it put its paw in the water for the first time and snatched a meal. In that fleeting moment began one of the oddest tales in the history of life. The odyssey of a mammal and its journey back to the sea.
All rise for the Paleo World theme. Good stuff. This was peak television when I was a kid. Oh, man. Good stuff.
To confront a whale is to come face to face with a paradox. These exquisite creatures are remarkably well adapted to life in the sea, yet their ancestors were born on the land.
That's true.
Until recently, no one knew where they came from. Their fossil tracks seemed to dissolve into the briny depths. What intrepid mammal millions of years ago seemingly reversed the course of evolution and set its sights on being a whale?
Oh, there's so much in that sentence that I would quibble with. Oh boy. Set its sights on being a whale. It's not how evolution works. Also, reversed evolution. Just because you go back into the oceans when your ancestors lived in the oceans and then later came up on a land, it's not reversing evolution. It's just adapting to a different ecosystem, So it's not reversing core. I don't know. That phrase just kind of bugs me.
Now a stunning cascade of whale fossils.
I mean, I understand why they said it there, because they're looking for an angle. Here's a story. There's an interesting idea. There's drama in that, It's a way to get people interested. That's also not how evolution works, Yeah, like Kennedy says, yeah, it's not planned. Set their sights on becoming whales.
Mammal millions of years ago seemingly reversed the course of evolution.
I guess they did say seemingly. Fair, okay.
And set its sights on being a whale.
And again, this almost gets into this idea of orthogenesis, that evolution is a directed process with an end goal in mind, and that's not how it works. It's just organisms adapting to local conditions generation by generation. And sometimes that there can be a trend in one direction for a long time. It's usually more of a zigzag in one direction, but yeah. Anyway. There you go, little double, yeah.
Now a stunning cascade of whale
sea
fossils.
Beagle. Welcome, Sea Beagle. It's good to see
from
you.
the ancient seabeds, each an exquisite link in a once broken chain. Sharktooth Hill, 75.
Does anybody know where this is, by the way? I'm sure Otter Dewitt knows where this is. Sharktooth Hill. And what exotic locale is this? Sharktooth Hill. Surely some faraway place. Exotic. Dr. Hub's already got it. Yeah, you gave it away. But it's near the exotic locale of Bakersfield, California, in the Central Valley. Yeah. Sharktooth Hill is today near Bakersfield, California. But at the time, about 15 million years ago, it was ocean. Shallow ocean. But there's modern day California, there's the outline. There's a map by Ron Blakey, circa 2006. There's Kern County, and there's Sharktooth Hill right there. So this area used to be underwater.
5 miles inland from the Pacific Ocean in central California is one of the most famous places in the world for finding fossils of sharks and ancient marine mammals.
Black whales, yeah.
Here, paleontologist Larry Barnes and his team have uncovered the remains of dozens of extinct sea creatures that lived 10 to 15 million years ago.
The place that we're sitting now was at one time the bottom of the ocean. And as evidence of that fact, here is this whale skull sitting at my feet. This is a wonderfully preserved skull. We can see here the brain case. This opening is where the nerve cord goes to the brain. The eye was under here. Magnum. The nostrils here.
Is there any other, I mean, do you want...
And Mr. Harrell says, lived in Bakersfield for 10 years in my youth. Oh, wow. Known for more for oil than fossils. I suppose. I mean, oil itself is what we call a fossil fuel. But yeah, no, you're right. Yeah. There's definitely a lot more money in oil than there is in fossils. Oh, boy. Yeah.
You want to put Glyptol anyplace else? We've got it. We might as well
No, I really don't want any more Glyptol on than we have to put on it.
Why?
Well, just...
For more than a century, the origin of whales has sparked one of the most heated debates in evolutionary theory. It began with the publication of Charles Darwin's The Origin of Species in 1859. Darwin believed that animals changed over time because nature selected those individuals with the most advantageous characteristics.
Nature select, it almost sounds like it's an active, thoughtful process, which it's not. But yeah, we talked all about this on Wednesday for Darwin Day. Old Chucky D, yes indeed, Emily. Yeah.
Survival of the fittest. But how could earthbound creatures sprout wings and land mammals transform their legs into flippers? Darwin concocted a hypothetical tale to describe how one animal might evolve into a totally different species. He had heard of bears swimming for hours with their mouths.
So this is one of those things that you still hear creationists talking about even to this day. But yeah, it was kind of a goofy idea. Darwin was trying to figure out, like, well, whales, where did whales come from? Let's do a thought experiment and let's get real speculative. Let's imagine an animal like a bear evolving into something like a whale. That's kind of where he's coming from.
Into a totally different species. He had heard of bears swimming for hours with their mouths wide open catching insects. So I can see no difficulty, he wrote, in a race of bears being rendered by natural selection more aquatic in their structure and habits with larger and larger mouths until a creature was produced as monstrous as a whale. For Darwin, it was a political mistake, and he realized it immediately. Critics pounced on the tale. Darwin wrote a friend that it is laughable how often I have been attacked and misrepresented about this bear. Vindication was not long in coming for some of Darwin's speculations. The year 1861 saw the discovery of a creature called Archaeopteryx, which was half bird, half reptile. What
Well, it's 100% both. Birds are reptiles, but
Darwin needed was an animal that was half bear, half whale, a link between the sea and the land. But there would be no discovery of a whale that could walk in Darwin's lifetime. Scientists did find early examples of whales over the next century, extinct whales unlike anything in the modern world, but they were all fully aquatic. There was no evidence of a link to land mammals. The search for a missing link would become a thorn in the side of paleontologists, according to Harvard biologist Stephen Jay Gould.
Here you have whales, who are obviously mammals. They give birth to the young live, they have hair, they have all the features of mammals, but they look so unlike any standard mammal. Mammals are creatures with 4 legs that run around on land. And one yearns to have intermediary forms, but the fossil record is very imperfect, and evolution is often very rapid.
I would actually, again, I'm nitpicking here. Somebody who works in this field. But yeah, I think Gould wasn't entirely correct about that. Evolution is often more gradual than he realized, but the fossil record is it's less imperfect than he realized too. A lot of that perceived like choppiness in evolution is because of poor sampling. But anyway, we'll talk about that another time.
Paleontologists know that evolution usually proceeds in rapid spurts followed by long intervals without change.
Yeah, this is called punctuated equilibrium, and I think a lot of that is often the result of poor sampling of the fossil record, that it seems so abrupt and choppy. Yeah. Maybe this time next year, we'll bring on Bobby Bosenecker, who is a whaleontologist. He studies fossil whales, and I think he feels more strongly about this than I do, about, punctuated equilibrium being largely an artifact of poor sampling in the fossil record. But yeah.
But in Darwin's day, evolution was perceived as slow and gradual.
It is often slow and
Scientists
gradual.
expected to quickly find the remains of a whale with legs, if such a fossil existed. But they were in for a surprise. The discovery would wait more than 100 years.
Sometimes that happens. Again, poor sampling. It's not because of a lack of fossils. It's because we don't have enough people going out and looking for them.
In Louisiana
and Kettlecook, this is very true. Yeah, manatees, not related to whales. Manatees are part of Afrotheria, which is a group of mammals that includes elephants and hyraxes and sengis and stuff like that, and aardvarks. A manatee is more closely related to an elephant or an aardvark than it is to a whale. They're completely different branches on the mammal family tree. We know this from their DNA, and we know this from fossils, too. So you're exactly right there, Kettlecook. Yes, indeed.
In 1834, paleontologist Richard Holland discovered the scattered remains of a huge animal. Holland mistakenly thought it was an enormous lizard, and so named it Basilosaurus,
meaning king lizard. Yeah. But it was a whale.
Although the fossils were incomplete, Holland was confounded. Basilosaurus was very old, yet looked like a modern whale. It was a fierce predator with flippers and a large fluke tail.
Yeah, so Basilosaurus, I've got a skull of it on my wall right here. A framed print of a Basilosaurus skull. This is such a cool animal. Yeah, they were pretty darn large. Really neat looking animals. There are, it's a lovely clip of one. Walking with Beast Basilosaurus. Bingo. There's a Meratherium right there on the shore. Kind of a proto-elephant, almost. Uh-oh. As the tide comes up, you better make a break for it, Meratherium. Again, Basilosaurus, not a dinosaur, not a reptile even. Oh, it's a whale. It was kind of misnamed, and we got stuck with the name. Casey Snowart, thank you for the raid. How are you doing? How was your stream, Casey?
42 raiders have arrived to ask exactly that question.
I appreciate that, Casey. Welcome, welcome to Paleontologizing. Happy World Whale Day. I hope your stream was excellent, Casey. What kind of cool art did you get up to today? We are about to see a Meratherium become a meal for a Basilosaurus. So like an elephant ancestor become a meal for a whale ancestor. Uh-oh. Uh-oh. Oh, no. She's beached. Mayor Theory was getting away. Uh-oh. Oh, boy. So, yeah. Yeah. Epic fail, says Bob Fat Records. Welcome, Bob Fat Records. Hello, hello. Casey says we were doing a painting of some large creatures soaring through the clouds. Very cool. Very nice. Well, I hope it was an excellent time. If anybody's not yet following Casey Snow Art, you are missing out. She does some really cool art here on Twitch. And if you want to learn secrets of doing cool art, give her a follow. Yeah. There we go. There's a piece very relevant to today that she did. Various species of whale here, including a vaquita, a beluga, a humpback, a narwhal. Very cool stuff. So anyway, Casey does some excellent, excellent work. Go give her a follow if you're interested in art. I always appreciate getting to point folks toward more safe for work educational content on Twitch. Thanks, Casey. I appreciate that. Yeah. Again, go follow Casey Snow Art if you haven't yet done so. Anyway, that's Basilosaurus, that ancient whale. This critter here. Yeah.
Although the fossils were incomplete, Harlan was confounded. Basilosaurus was very old, yet looked like a modern whale. It was a fierce predator with flippers and a large fluke tail.
Yeah.
With the oldest known Basilosaurus, paleontologists had...
And multiculturalist James. Oh, welcome back. It's good to see you. Yeah. D&D book dedicated to dinosaurs. Immediately thought, oh, very cool. Well, thanks, multiculturalist James. It's good to have you.
Pushed the origin of whales back 40 million years, but there was still no hint of a missing link.
Yeah. And thank you, Salamander, for gifting on
Sloppy
Goy.
Salamander gifted a tier 1 sub to Ingoy 1. They have
thank you,
given
Salamander.
190 gift subs in the channel.
Good stuff.
Then, in 1989, in a remote desert in Egypt, Philip Gingrich of the University of Michigan discovered another Basilosaurus fossil. This Basilosaurus had legs. The legs.
And Oscar Jr.'s.
Amazing! 70 million year old dinosaur eggs, and they're perfectly preserved.
I appreciate it.
Cool!
Thank you, Oscar Jr.'s. Appreciate that Prime very much. Thank you, thank you. Enjoying not having to watch any ads.
Were beautifully formed, but they were
Good
no
whale
bigger than
legs.
a man's arm. Too small to support an animal 50 feet long, weighing as much as 20 tons.
Huh.
So, what were they used for?
What were they used for? Maybe nothing. But maybe they were used for... Oh, we just had Valentine's Day last week. Maybe you can imagine what they were used for, potentially.
I think they had to have some function, and it wasn't locomotion. I think they probably were used as copulatory guides, used to hang on during mating, which is,
Maybe.
after all, very important in evolution.
That's true. Yeah.
The revelation that Basilosaurus had legs was tantalizing. It meant there had to be another, even older creature that could live and walk on land. Then, in a series of dramatic discoveries, the mystery was solved.
Thank you, Dr. Hubbs. Yeah, we saw Phil Gingrich in a video earlier, sometime after 1994, and I said, remember that face and that name. You'll see him in this documentary, too.
The first big break came in 1983 in Pakistan.
And thanks,
50
Casey. I
million years
appreciate
ago,
the
this
raid.
was the
Have a
shore
good
of
meeting.
an ancient sea called Tethys that stretched all the way from Spain to Indonesia. but continental drift was rearranging the Earth's surface. India, then a separate landmass, was colliding with Asia, pushing up the Himalayas and emptying the Sea of Tethys.
As India moved north, the sea became shallow, and that shallow sea became saline, and the high salinity and the exposure to sunlight made it highly productive. Now, plankton eat the nutrients in the water, fish eat the plankton, and the importance for whale evolution, I think, is that there was a big fish resource there waiting to be exploited.
Nice.
Scientists believe it was here that mammals first ventured back to the sea, and it was here that Philip Gingrich was looking for one creature and found another.
Yeah. Salamander says, so sharks were under an evolutionary pressure that claspers provided an advantage in dealing with, but whales did not face the same pressure? I guess so, Salamander, yeah. And I bet you the claspers on sharks have gotten smaller over time. Claspers are also only on the male sharks, whereas presumably the legs were on male and female Basilosaurus, because they're like hand-me-downs from their ancestors. But, yeah.
What he found were the bones of an animal which on closer examination was clearly an early whale, 10 million years older than Basilosaurus.
Yeah.
Gingrich named the new whale Pakicetus, whale from Pakistan.
Here we go.
By reconstructing the skull of Pakicetus, Gingrich confirmed what many had long suspected, that whales evolved from a strange wolf-like animal with hooves called a mesonechid.
Yeah, mesonychids are no longer considered to be the ancestors of whales, but a relative of mesonychids instead. But anyway, so this is an interesting time capsule here. This show from 1994 kind of harkens back to, yeah, this brief window where mesonychids were thought to be the ancestors of whales. Mesonychidae. It means middle claws.
Shudder at history's most ferocious killer, Tyrannosaurus Rex.
Chill Bill, thank you for the follow. Welcome, welcome. Yeah. So they would look something like this. Yeah. Mesonychid taxonomy has long been disputed, and they've captured popular imagination as wolves on hooves, animals that combine features of both ungulates and carnivores. Yeah, skulls and teeth have similar features to early whales, and the family was long thought to be the ancestor of cetaceans, whales. Recent fossil discoveries have overturned the idea. The consensus is that whales are highly derived artiodactyls. And some researchers now consider mesonychids a sister group to either whales or artiodactyls, close relatives rather than direct ancestors. Other studies define mesonychia as basal to all ungulates, occupying a position between Perissodactyla and Ferae. Interesting. So we don't really know where this group belongs nowadays. That's disputed. But there's a general agreement that they're not the ancestors of the whales. They might be really close to the ancestor of whales, which is why they look so similar to things like Pakicetus. But we're still not totally sure. What's funny is that the ancestry of whales has become more and more clear, and this group that was known before that, mesonychids, has kind of become more mysterious. We're not really sure where they belong now. So, fascinating stuff. Yeah.
Here's a skull of a mesonychid and the skull of Pakicetus.
Yeah.
If you
They do look
compare
similar.
them, you see that they're very similar to each other. And the main difference is that the front teeth in Pakicetus are smaller and much more pointed, which we interpret as being fish-eating teeth, whereas mesonychids like this.
When Jim says, we are sure, nothing to do with whales. Jim, it's good to see you. Howdy, howdy. You would know better than I would, Jim. Shoot, I was just going based on what it said there on the Wikipedia page. I know next to nothing about mesonychids. And Jim here is state paleontologist for the state of Utah, for those of you who don't know him. Most of us know Papa Jim, though. Jim is saying, no, there's a good consensus now that mesonychids are nowhere close to whales. Huh. And Jim also says, no whales in Utah, biggest hole in our fossil record. That's interesting, Jim. Do you have, like, post-Eocene marine rocks in Utah? Was there an inland sea in Utah after the Paleocene or Eocene? Huh. Anyway, and Distiller, good to see you. Welcome, welcome. Good to see you. Yeah. And Jim, the GOAT, the greatest of all time? I agree, Elmeta. Indeed, hippos are related to whales. Goniatritus, yeah. Yeah. So... There we go. Whales and hippos form a clade together called Whippomorpha. Zoom into the hippos here. Masito Agua, thank you for the follow. Welcome, welcome. It's good to have you here. Yeah, there's the hippos, hippopotamuses. So they're part of a larger group called Whippomorpha, which is hippos plus whales. So they belong together here. And then outside of that, you get into the other artiodactyls here. Things like deer and pronghorn and giraffes and bovids, cows, etc. They all form this clade together. So I think, from what I understand, and I could be wrong about this, Jim, but as I understand it, mesonychids, we're not really sure where they belong. Are they basal to this group here? Are they just basal to where Whippomorpha is? Are they more basal than that, and they kind of form... like, they're a clade somewhere here, like between the carnivorans and the perissodactyls and the artiodactyls, or what? I think we're not really sure. What does basal mean? Fat Bob Records wants to know. Basal just means ancestral, like closer to the bottom of the tree. So like on the tree of life like this. So, let's see. This clade right here, the artiodactyls, cloven hoofed ungulates, would be basal to this clade here. It's more primitive. It's further back in time. It's closer to the base of the tree. More basal. Closer to the base. Does that make sense? We can go back further and further and further down the tree, down to like amniotes. So Amniota as a clade is basal to Mammalia as a clade. It's closer to the base of the tree, more basal. Yeah. So like an amoeba is the base, says Fat Bob Records. Kind of. We can... something like that. There's some sort of single-celled organism, maybe kind of like a bacterium or something, that would have been the base of the entire tree. Down here. About 3 or 4 billion years ago, that one ancestor lived, and then all life on Earth evolved from that. Different forms branching off and going their own ways and diversifying, adapting, evolving, until you get to this, you know, this grand and beautiful tree of life like this with all the millions of species around today. Oh yeah. Yeah. And Jim says mesonychids would be basal ungulates. Interesting. Because that's... yeah. Yeah, again, I don't work on fossil mammals. You would know better than I would, Jim, what the current consensus is. But yeah. Anywho. So here we are, getting back into mesonychids and stuff.
Their teeth more for bone crushing and meat tearing.
Mesonychids lived along the edges of the Sea of Tethys 50 million years ago. The teeming fish and other sea creatures in the waters of Tethys must have been a tempting sight. The main fish-eating predators, the giant marine reptiles such as plesiosaurs and mosasaurs, had gone extinct 10 million years earlier. For any land mammals willing to venture out from the shore, there was little competition from other animals for the abundant seafood that filled the waters of Tethys.
And it's pretty realistic.
If you have a shallow sea full of fish, the fish are going to die all the time. The fish wash up on the beaches, and a scavenger soon learns that there's a good meal on the beach. Pretty soon they're in the water catching the fish before they wash up. Pretty soon they're chasing the weak and the dying fish. Pretty soon they're chasing the living fish, and I think pretty soon you have a whale making its living by eating fish.
That's one way to do it, I guess. This almost looks like an entelodont here. Entelodont. What?
Evolving from the Masonichids, Pakicetus had developed not only fish-eating teeth, but also a
What in the world? Bad illustrations
thickened ear pad for hearing underwater.
Oh, we're talking about the involucrum here. Specialized ear of whales. Here. I wonder if we can find a video on this real quick, because I do want to talk about this. I just finished 3D printing one, so we'll snatch that off the printer in a minute. But, whale involucrum. Here. We'll take a look at a PBS Eons video that I think gets into that.
We know whales as graceful giants. Some are powerful hunters, some are gentle filter feeders, but no matter what they eat or how they live, whales, as we know them, are bound to the sea. But there was actually a time when whales could walk.
Yep. Yeah.
The tale of whale evolution is a story about one of the most remarkable transitions in the history of mammals. The fossil record shows how these animals transform from tiny four-legged plant eaters no bigger than house cats to the
I'll see you later, David
giants
BC
we
Man.
know
Thanks
today.
for being here.
This change was dramatic and kind of fast. Fossils from over the past 50 million years have revealed whale-like animals of all shapes and sizes, each like a piece in the puzzle of whale evolution. Smack in the middle of this amazing transformation is Ambulocetus, a toothy predator the size of a sea lion, and a striking example of a mammal order in transition. Ambulocetus lived about 48 million years ago in what is now northern India and Pakistan, and its full name, Ambulocetus natans, literally means the walking, swimming whale. But scientists will tell you that it wasn't really great at either. In the water, it was a powerful swimmer, but not very fast or efficient. On land, it was clumsy too, with legs that splayed out to the sides, a belly that almost dragged on the ground, and a snout that was so long and heavy it looked like it could barely lift its head. But Ambulocetus was perfectly equipped for its environment. It lived in partially freshwater environments like river deltas, where it lurked in the shallows and grabbed whatever prey that came near its giant snout. Now, if a long aquatic ambush predator sounds kind of familiar, that's because Ambulocetus is basically the mammal version of a crocodile. It lived a lifestyle that was a lot like a crocodilian's, ideal for an animal that lives between the land and water. But despite their similarities, crocodiles and whales are not directly related at all. In fact, the group of mammals that includes whales and dolphins, known as cetaceans, are so different from other living mammals that it's been hard to figure out what exactly they evolved from.
So that was a big mystery for a long time. Like, kind of up until, I'd say, the 1970s and 80s. Really up until the 80s. It's a huge mystery, like, what mammals are whales related to? We know that they're mammals. We know they feed their young with milk. They've got hair. They've got a mammalian skeletal structure. They are 1,000% mammals. Of course they're mammals. But what kind of mammal did they evolve from? Where did they come from on the mammal family tree?
Interestingly, research done in both the field and in the lab revealed some surprises. First, in the 1980s and 90s, a set of genetic studies took sequences of DNA from whales and compared them to the same sequences in other living animals. And these comparisons showed that the cetaceans are actually most closely related to a group known as artiodactyls.
Yes, indeed. So DNA evidence started to show this back in the 80s. Like, oh shoot, artiodactyls, hoofed mammals. What? And then more fossils started to be discovered that sort of started to make this make sense.
Hoofed mammals that includes hippos, pigs, and deer. Then a number of fossils found a little later seem to support the same conclusion. In 2007, paleontologists in Kashmir, India found the fossils of a 47-million-year-old hoofed creature the size of a house cat that they named Indohyus. It turned out that this tiny mammal had a specialized thickened ear bone that, until this discovery, had only been found in whales.
So this is called?
The bone, called an involucrum, helps aquatic mammals here underwater, and it shows up even in the earliest cetaceans.
So this involucrum is something that I just 3D printed. We're going to go snatch that off the 3D printer, and I'll show it to you. Here. There we are. Now let me take the supports off so you can actually see what it looks like. There we go. That was easy. Don't you love it when it comes off in one nice clean piece? But this is the involucrum. This specialized ear bone that today is only found in whales. So when this thing was found in this fossil organism, Indohyus, it's like, oh shoot, why does it have this special whale ear bone? Well, this animal is from the time and place that we expect to find the ancestral whales. It fits perfectly. This is an ancestor of whales, or at least this is part of the clade that whales evolved from. Whether whales evolved directly from this particular genus, Indohyus, or not, doesn't really matter. What it shows is that there's a group of animals bopping around at this time that whales came from, and they've got that special, unique whale ear bone. This thing is incredibly distinctive. No other critter has got an ear bone like this. So it's very much a special whale thing. If you've got this, it's because you're a whale or an ancestor of whales, essentially. Yeah. Pretty neat. Pretty neat.
Support the same conclusion. In 2007, paleontologists in Kashmir, India found the fossils of a 47-million-year-old hoofed creature the size of a house cat that they named Indohyus. It turned out that this tiny mammal had a specialized thickened ear bone that, until this discovery, had only been found in whales. The bone, called an involucrum, helps aquatic mammals here underwater, and it shows up even in the earliest cetaceans. It also had other adaptations for life in the water, like really dense leg bones.
It's a one-to-one replica. This might be slightly too big, actually. So I think this is from, I actually don't know what kind of whale this is from. I tried to print one from a sperm whale, and the file was corrupted. This one just said generic whale. No information on the genus or species. So it's from some kind of whale, but this is from a modern whale right here, the involucrum. Yeah.
Walking through a river. But Indohyus wasn't a cetacean. It had forelegs and hooves, for crying out loud. It even had a special ankle bone called an astragalus, shaped kind of like a pulley, and that feature is only found in artiodactyls. Some very early cetaceans have.
So what makes it not a cetacean? I think Indohyus might be a cetacean. Let's look that up real quick, actually. Indohyus. Is it part of? Rowellidae. Huh. So they're part of Whippomorpha, so it might not be. It's just this group is a missing link sister group to whales. So okay, so Indohyus itself would not be on the direct line to whales, but it would be closer to whales than it is to hippos, essentially. I think that's the idea. Yeah.
This ankle bone too, which tells us that cetaceans evolved from artiodactyls. So Indohyus is now largely considered the closest.
And First Anomaly says, I was taught in school to mistrust Wikipedia. that's the thing. I don't... So, here. I'll tell you this. I know a lot of people feel this way about Wikipedia. Don't trust Wikipedia as a source. Trust what you see in the references in Wikipedia if it links you to the original literature, especially in the sciences. So, I don't know. I work on dinosaurs in particular. Dinosaurs are what I study, what I publish on in the scientific literature, all that stuff. I don't know how good Wikipedia is for other fields that I'm not an expert in, but for what I am an expert in, for dinosaurs, Wikipedia is the single best concentrated source of information on dinosaurs anywhere on the internet. It is the most comprehensive. It is the most up-to-date. It's the easiest to find, like, references. If you look up, I don't know, give me the name of an obscure dinosaur taxon, chat. Some obscure genus of dinosaur. Let's see, what do we got? Machiacosaurus. There we go, Mayor Space. That works. Yeah. Machiacosaurus, known from one specimen, as far as I know, from Madagascar. Machiacosaurus. There we go. We've got a lovely article here. History, description, vertebrae, forelimbs, classification. We've got a phylogeny right there, paleobiology, diet, growth, and look at these references. The references are what make Wikipedia. If you want to actually learn about this dinosaur and look at the original scientific literature, the best place to find that compiled online is going to be Wikipedia. You look at those references there, and not only will you find the original descriptive paper from 2001, but a bunch of follow-up stuff as well. Other papers that have been published on it. Basically, if there's been scientific work done on this dinosaur and it's been published in the literature, there will be a reference to it on the Wikipedia page. And that's true for just about any dinosaur you can think of. So don't trust the summary necessarily. Parts of that, there could be mistakes, there could be things that are potentially out of date, although with dinosaurs it tends to be really good. But go down to the references and read the original scientific literature if that's what you're after. It's phenomenal. So, Wikipedia, let's compare this to, say, a legacy publisher, something like Encyclopedia Britannica. Well, let's look up Machiacosaurus in Encyclopedia Britannica, shall we? Machiacosaurus. Nothing. Nothing. There's no article on Machiacosaurus. Doesn't exist. No, Claire Burr. Let's think of another dinosaur. Let's think of Haplocanthosaurus. Again. Nothing. Let's think about... Jim is here. Let's do Gastonia. The dinosaur. There's a town called Gastonia, North Carolina. But the dinosaur. Not on here. Let's try Utah Raptor. Everybody knows Utah Raptor, right? No article for Utah Raptor. So yeah. Let's try Wikipedia. Utah Raptor. Here it is right there, you know? Pretty decent article. A lot of the most recent stuff that's not been published will not be in here, but if it's been published, it will be on the Wikipedia page. You know? Look at those references right there. Look at that. It's impressive. It really is. 46 different references, both in the scientific press and the scientific literature, and also links to websites, links to press articles, stuff like that. It's all there. So it's good stuff, you know? Yeah. Anywho. Wikipedia is a wonderful springboard for your own learning about dinosaurs in particular. But also, not just for dinosaurs, but things like, you know, ancient mammals, or fossil organisms. I can see this. Pretty good article here. Decent number of references here. 16 of them. Not too shabby. They're probably pretty good quality. Let's search evolution of whales, for instance. Evolution of cetaceans. There we go. An excellent video. Excellent video, excuse me. Excellent article, I would say. This is pretty good. And you're gonna have have links to different families of fossil whales. Remington Acetidae right there. A whole article about this. These critters. So, yeah. A lot of the information that you're going to find online about dinosaurs or about other fossil organisms or stuff in general might be pretty lousy. But at least when it comes to dinosaur paleontology and maybe vertebrate paleontology in general, Wikipedia is generally a pretty good source. So don't say, oh, it's Wikipedia, must be lousy. Wikipedia, in my opinion, is the single best concentrated source of information about dinosaurs that you'll find anywhere on the internet. So yeah. But sometimes information is just plain bad, and we'll take a look at this. I kind of promised this earlier. I think I promised this in the Blue Sky post, didn't I? Yeah. We're discussing whale origins, cetacean evolution, the fossil record of whales, and why creationists are so upset about all of it. That's what this video is about. We're about to dive into a little video here from a creationist organization, and they must have paid a fortune to have this produced because it's very slick. There's going to be a lot of misrepresentation, a lot of misinformation, probably some outright lies. I haven't actually watched the whole thing yet. We'll take a look here, and we'll use this as... there's going to be a lot of teachable moments in here to talk about what we actually know about whale evolution. Hopefully we don't get too frustrated, because as slickly produced as this is, they might get real weaselly with some of this stuff. I might get pretty frustrated. We'll see. But, let's take a look.
You want to hear something silly? Bears can't parallel park.
So, what? Again, this is going to be a very slick, professionally produced video. Meant to mislead you about whale evolution.
You want to hear something even sillier? Darwin thought that bears could turn into whales.
I'm glad that we watched that other video earlier, because when old Chucky D was... Here, let me find the right... Not Italian subtitles, we want English, thank you. When Darwin was trying to come up with a thought experiment for how you could have whales evolve from a terrestrial mammalian ancestor, he just kind of went, oh, bears, I guess? He didn't think that they did evolve from bears necessarily. But anyway, they're going to really run with that in this video to try and make the idea seem ridiculous that living things change over time because Darwin thought bears could turn into whales. It's like, there's a name for this logical fallacy. I kind of forget what it is. I'm not particularly interested in like the taxonomy of logical fallacies. A lot of that's kind of onanistic, but yeah.
Back in the 1800s, when Darwin first published The Origin of Species, this is exactly what he said. And he was brutally mocked by scientists of his day for thinking something so ridiculous. He even retracted the idea from later editions of his book. But here's the kicker. Scientists of today think essentially the same thing.
And no, we don't. I mean, yeah. Again, that's why this is so frustrating. Let's continue.
Stupid Darwin thinks bears could have turned into whales. How ridiculous. Everyone knows these wolf, pig, weasel, hippo things or it turned into whales. My, how the tables have turned. Back in the 80s and the 90s, a series of fossils were found that rocked the evolutionary landscape. Paleontologists thought that they had found a clear transitional series of fossils documenting the evolution of whales.
And so this is the consensus, is that, yeah, shoot. You go back to where it would make sense for whales to have first evolved, and back to the correct time for whales to have first evolved, and you look for fossils there, and bingo, they turn up. And they've got those unmistakable hallmarks of whale anatomy, like the involucrum, something that no other critter has, absolutely unique to whales. So this is essentially a smoking gun. Creationists are very upset about this because they don't want to believe that living things change over time at all, over millions of years. They don't even believe in the concept of millions of years if we're talking about young Earth creationists. So how are they going to try and square this circle? We have the evidence, we have the fossils, we've got the DNA evidence, we've got those unique anatomical traits between these fossils and modern whales that are, it's incontrovertible, right? I legitimately don't know how they're going to try and argue their way out of this. Well, let's see, I guess. Oh boy.
University of Chicago evolutionary biologist Jerry Coyne says in his book Why Evolution is True, whales happen to have an excellent fossil record, courtesy of their aquatic habits and robust, easily fossilized bones. This is one of our best examples of an evolutionary transition.
And it honestly is. If we're talking about like big macroevolutionary chains, then this is one of them.
Wow, one of the best. Let's take a look at the story behind whale evolution. Is it a good argument or not?
Oh boy, this is going to be bad, isn't it?
So according to Coyne, whale evolution is such great evidence since we have a chronologically ordered series of fossils, and it goes something like this. The sequence begins with a raccoon-sized animal called Indohyus, living 48 million years ago. 52 million years.
So they're, oh boy, we're already getting some oversimplification here. So I think what they're going to say in this video is, oh, well, you know, it's supposed to be this nice, smooth transition, but then you get these weird branches off to the side and it kind of gums everything up. So it's not as smooth as the evolutionists claim. No, we don't expect it to be smooth. It's like we were talking about earlier. Remember that, you know, like complex tangled bush of whale evolution? That's what we talk about, and that's what the fossil record shows. I'm guessing this is going to be a straw man kind of a thing where they're going to lay out, oh, this is a smooth transition that the evolutionists claim, but it's not actually that smooth, so that means evolution can't be real. But we'll see.
Years ago, we see a wolf-sized creature called Pakicetus, which is a bit more whale-like than Indohyus. At 50 million years ago, there's the remarkable Ambulocetus. Rhodocetus, 47 million years ago, is even more aquatic. Finally, at 40 million years ago, we find the fossils of Basilosaurus and Dorodon, before we have our modern whales. Let's take a look a little bit closer at this chronologically ordered series of fossils.
Ooh, I don't like those quotation marks.
If you're paying attention, you might be thinking something fishy is going on here, but no, you'd be wrong. That would not be a bad pun because whales are mammals, not fish.
Well, fish are, strictly speaking, a kind of Sarcopterygian fish. Mammals are fishes, but just being pedantic.
But also, yes, something mammally was going on here. Granting the standard Darwinian dates for these fossils.
Darwinian dates. Oh boy. These are not Darwinian dates. This is geology. These are the same exact processes that we use for doing things like exploring for petroleum. The same processes that you use to date these rocks in order to figure out how old the fossils are, used for doing things like finding oil. There's a reason why petroleum companies don't hire geologists who think that the Earth is only 6,000 years old. Because if you do that, if you think that all of geology is a lie, you're not going to find oil or natural gas or anything else that you're looking for in the rock record. There's a reason why oil companies rely on the actual dates that geologists have come up with rather than, like, you know, creationist stuff. We're like, oh, it's got to be less than 6,000 years old because we say so. There's a reason why they don't do that, you know? But yeah.
Fossils. Indohyus is dated as far younger than his supposed descendants, and he's not the only one, more on that later. This is common practice in evolutionary analysis, to ignore where species actually show up in the fossil record and place them wherever makes Darwinian sense.
Again, this is what I'm talking about. This is the straw man argument. Indohyus is not a direct ancestor of whales. We just looked that up a little while ago. And I don't think anybody claims that it's a direct ancestor of whales. You know what I mean? It's just... It's like oversimplifying the evolutionary record and then pointing out, oh, that's oversimplified. Must be wrong. No, you're oversimplifying it to start with. It's so frustrating, you know?
Creating what are called chronological inversions, or ghost lineages. Oh, that's so spooky. The fossil record often reveals fossils out of the order that they're supposed to be in. For just a couple of other examples, let's take a look at bird evolution. It's supposed to go theropod dinosaurs evolving into birds, with the fossil Archaeopteryx being evidence of this.
So now we're getting into theropods too.
As an
oh boy, this is going to be the same arguments that the band people like Larry Martin made back in the 90s.
Intermediate fossil. But the problem is he appears long before the dinosaurs he was supposed to have descended from.
Which is not true. Nobody says that dinosaurs like Deinonychus evolved into Archaeopteryx. I mean, they're outright... Whoever wrote this is outright lying. It's a misrepresentation. It's so frustrating that, like, I don't know. I guess if you want to argue that the Earth is only 6,000 years old, like, you better be prepared to lie and misrepresent and twist the facts and the data and everything, because there's no way that you can win actually playing by the rules, you know? It's so frustrating. Dinner is at 8. Thank you, Lordy. Okay. Appreciate that. I don't know.
Evolution also got a big stick in its spokes with...
And Paleo Jim says Deinonychus came out of early birds, and that's a new idea. We talked about this, Jim. Yeah. I remember when we were looking at the Utah Raptor Mega Block. Let me see if I can find that. There we go. Well, there's a new idea that dinosaurs like Deinonychus actually evolved from, well, maybe directly out of birds, but that's kind of the newish idea. But, yeah. It's self-evident that Deinonychus and Utahraptor and critters like that would have evolved from the same ancestor as birds, because they're part of the same clade, Maniraptora. There we go.
You know, and as a colleague, James Napoli,
True.
you can follow their stuff as well, their blogs. He thinks potentially it's going to turn bird origins over on its head.
So it could turn out that dromaeosaurs like this would turn out to be part
Closer
of the bird
to
lineage.
bird origins than Velociraptor Deinonychus,
Right.
who offshoots, you know, that went nowhere, but they diversified radically.
Yeah.
I think so.
I think
Go
so.
out there. Hopefully, I'm trying to think what we're going to look for. I was tuned in for a little bit. So.
Nice.
You got the...
Crimson Carnotaurus says, hasn't the idea of dromaeosaurs coming from birds an idea that's been around for over a decade? It's been around since the 60s, I think. I want to say that Ostrom hinted at that back in his description of Deinonychus back in 1969.
Yeah, we'll be out digging with Don and Jim.
Greg Paul's been talking about it for a long time, too.
Yeah.
Back into the 90s.
Yeah.
But yeah.
Awesome.
Anyway, and people say, well, why are you going out there? You got so much to write up. Give me 70.
Anyway. Yeah, I don't know. That's why this is so frustrating, is that it's done in a subtle way and it's very slick. Like, this is a well-edited video with all these original animations and drawings and everything, and they try and throw a lot of humor into this. And it's frustrating because they can't actually argue on the basis of facts as we understand them. They've got to distort everything in subtle ways in order to be able to make an argument.
With this guy, Tiktaalik.
And John Ostrom first, says Paleo Jim. Yeah, that's what I thought I remembered reading his description of Deinonychus at the time. But yeah.
A fish-like creature that was for years crowned as the smoking gun transitional fossil of fish starting...
No one claims that Tiktaalik was absolutely the ancestor of all the tetrapods. Again, this is a misrepresentation. It's literally not how evolution works, and that's not how paleontologists view this kind of thing. It's a misrepresentation.
To go from the sea to the land. Brilliant evidence, just what they expected. Until in 2010, fossil footprints of true tetrapods were found in Poland, long before they were supposed to have evolved.
And that is still controversial to this day. I don't think we actually have a super strong consensus that these are dated correctly or that they actually are the footprints of true tetrapods. I mean, but again, I'm kind of falling into the creationist trap here where the whole point of this video is to try and sow doubt about the fossil record and be like, well, if this little tiny thing is slightly out of date, like if these things are slightly inverted in the stratigraphic record, then, oh, well, that means nothing changes over time and the Earth is only 6,000 years old. It's not just throwing the baby out with the bathwater. It's nuking the town that the bath and the baby are in. And you're supposed to go, well, that baby shouldn't have been taking a bath or something. Serves him right for getting thermonuclear struck. I don't know if that analogy makes sense, but it goes beyond throwing the baby out with the bathwater. It's, I don't know, and I'm falling for the trap here because they're trying to say, oh, well, this little thing might be wrong, so that means you should throw out all of evolutionary biology. I'm going, wait, but that thing isn't actually wrong. And I'm ignoring the larger point that they're making, where it's like, oh, we should throw away all of evolutionary biology. You know what I mean?
And all of a sudden, Tiktaalik was...
It is gish galloping for sure, Dr. Morbius.
Because again, the dates are all out of order. Hey, everybody, I'd like you to meet my grandpa. Oh, so cute. Is that his name, or... No, his name is Seymour. He is my grandpa.
So again, what's funny is that this kind of technique of trying to use humor and kind of caricature science in order to try and ridicule it and get you to dismiss science entirely, this is a tactic that creationists have had since Duane Gish. That's where the term Gish Gallop came from, Dr. Morbius. Here's a video that I timestamped earlier. This is Ken Miller talking about this back in the 90s. Talking about debating creationists with regard to whales, too. I'll pull that up for you.
This is a shrimp from the Jurassic, and you can look at it, and you know exactly what the shrimp looked like. You could even imagine ways to cook it. This is a teleost from the Eocene, and these fish from the Green River Shale Formation in Wyoming are exquisite. You can see everything that's there, and you know exactly what's going on, and you know the right way
mentology.
to
There you go,
describe this
Kako,
particular
yeah.
organism, and even to classify it. You can show slide after slide, which will point out the richness of the fossil record and the degree of information we have about fossil species, and you really ought to do it. Because if you don't, they will be left pretending that evolution hangs on a few fragmentary bones and tooth fragments and a lot of speculation, which isn't true.
So this is a talk that that Ken Miller, who actually we talked about on Wednesday, didn't we? He showed up in our Darwin documentary. So Ken Miller has been a tireless advocate for teaching people about evolution and fighting against young Earth creationists. And Ken Miller is particularly good at this, not just because he's really passionate and knows his stuff. Like, he's a very accomplished biologist. He's also a devout Roman Catholic. And so when you're arguing with creationists who, their prime motivation is to try and uphold whatever particular religious doctrine they have, their specific, like bizarre sect of, religious belief that says, oh, the Earth has to be 6,000 years old, or else, that means that you're a godless heathen. Ken Miller can go, excuse me, devout Roman Catholic here. Not only you're completely wrong about the science, but you're completely wrong about the religious implications as well. He's very, very good at this. And so here's him giving a talk about this back in, I think, the 90s.
Finally, I think
here we go.
The seventh
the whales.
lesson is personal behavior. And this is the final lesson. And that is that when you debate, you have to act in a certain way. And what I mean by the certain way is, first of all, and I don't have to tell this to people who are used to working in the public area like Fred or anybody else, but you do have to tell it, unfortunately, sometimes to scientists. And that is, you never, ever, ever pull rank. Which is to say, you never ever hold your degrees up against somebody else's degrees. You never say you have more publications. You never say you're more eminent. And unfortunately, some scientists can get into that sort of thing. And the reason you don't do it, first of all, is because it's pointless to the scientific argument. You don't argue within science that way, and that's not how science works. And second of all, it doesn't look very good. It looks as though failing to win on the evidence, you have to win on credentials. And audiences, any audience, sees through that immediately.
Yep, that's
the
good
second
advice.
thing is you have to use your common sense and retain your good humor. When Gish
Humor.
or Morris or whoever you happen to be facing makes a joke, usually they're funny and they're worth laughing at, and you should go ahead and laugh at them too.
So this, this whole thing is, supposed to be using good humor. It kind of falls flat because it's just sort of very cringe. Kind of like homeschool humor. But here we are. Miller's talking about this here.
But the corollary to that last point is, wherever possible, deny your opponents the use of a joke. And Fred has made this point as well, and there's nothing quite as good as the preemptive joke. And it's a very, very useful debating strategy. Dwayne Gish, as Fred has mentioned before, and I can't remember if he mentioned this talk or not, has this wonderful slide where he'll start to ridicule evolution. He'll show a slide of a chimpanzee, and all of a sudden say, oh, how did my uncle get in there? And then he'll go on to another slide. Well, if you know that's coming, and I knew it was coming, I arranged to speak first. And I pointed out to the audience that I had the utmost respect for Dr. Gish, who has a PhD in biochemistry from the University of California at Berkeley, and it's a wonderful school. Not very good at football, but a wonderful school. And one of the things that Dr. Gish and I have tried to do is to get together before the contest and get things over and try to have this in a friendly and upright way and concentrate on the issues, make sure you can all understand what's going on. And Dr. Gish and I have known each other for a long time. Now, I don't know how you feel about your baby pictures, but when I have baby pictures of myself, my friend, my brother, or my sister, I have trouble picking out who's whom, and I have the same problem here. If you do that, Gish has lost one of his best jokes. Another thing that Gish will do is, wherever possible, if he can't anticipate a joke, turn it around and make it into a serious scientific point. Dwayne Gish likes to quote from several people who work on cetacean evolution, the evolution of whales, and dolphins and porpoises, to say that these organisms probably evolved from a cow-like terrestrial feature, a cow-like terrestrial organism. And then he has a wonderful cartoon. My wife is an artist, and I asked her if she'd sort of reproduce it. And unfortunately, she did a better job than his artist did, but it's not quite as funny. So what he argues is that if they evolved from a cow-like creature, what the evolutionists want you to believe is we've got an organism like this with udders and a blowhole and so forth and so on, and that must be the intermediate form, and it looks silly and everybody laughs. Now, if that happens before you, what you have to do is be prepared to repair scientific damage. And you repair scientific damage by saying, yes, that's pretty funny. But when you look at the serious evolutionary record of cetaceans, in other words, you look for fossil whales and you look for fossil dolphins, do you find anything that makes sense, or does it look like sudden creation? Well, if whales evolved from terrestrial organisms that have their nares, their nose opening up front, like all terrestrial organisms do, and evolved into creatures with a blowhole, which is the way you'd like to have it if you had to surface occasionally, go up and down the ocean, you ought to find intermediates where the nose, the nares, the nose opening sort of moves to the top of the head.
Yep.
Lo and behold, you find them. There are a series of whale-like fossils. which date from the period about 40 or 50 million years ago.
And this is, again, back in the 90s before a lot of the ones that we have today had even been discovered or anything. So again, this is really incomplete information that they're working with in the 90s, and still you've got this beautiful transition.
Which show the gradual backward movement of the nostrils from the point in front to the point just between the eyes, and then gradually to the point on the top of the head. So even where your opponent makes their best jokes, when you look into the scientific...
Doo-doo, zoppity, bop, bop, bip, bop. Thank you for the follow. Welcome to Paleontologizing. It's good to have you here.
scientific evidence, you can find a...
And Scoobs and Multiculturalist James says, this is so cool. Didn't know any of this. Things are much cooler in the 90s. I mean, yeah. Yeah. I think this is a beautiful little time capsule, too, because it's kind of showing that these creationist arguments just don't change over time. It's just like, oh, boy. And even with limited fossil evidence in the 90s of whale evolution, still, you know, nowadays we've got so much more evidence. So the arguments that they make are even more out of date. But, shoot, Ken Miller was talking about this stuff back in the 1990s.
A serious scientific case for evolution, and that blunts it. Now, the last point I want to make is that you have to be careful in these proceedings, and you have to be wise, and you have to use good judgment. It's important to know when not to debate to avoid stirring up an issue that doesn't need stirring up. It's important to debate in some cases where the creationists have the upper hand. And the last point that I'd make is, in all likelihood, an evolutionary biologist or your local expert on evolution is probably the worst person to debate. And the reason...
And this is kind of the point that I was making earlier, too. Debates like this, I know the internet is obsessed with debates, like, oh, so-and-so destroys other person in the marketplace of ideas. You know, debating is gladiatorial combat on an intellectual stage. Debates are theater. In science, we don't determine what is best supported by the evidence by having a formal debate at a stage. Debates don't determine anything except who's a better speaker, or sometimes who can be more slimy when they're in front of an audience. I think that's I don't know. Debates are like blood sport, you know? It's not how you actually determine what's true and what's not. It just isn't, you know? A debate determines who is better at debating, not which ideas are actually closer to the truth. And the point that Ken Miller makes here, where sometimes the worst person to represent science in a debate is a scientist.
Evolutionary biologist or your local expert on evolution is probably the worst person to debate. And the reason for that is that those people tend to be more concerned about issues of evolutionary theory, and they're aware of the tremendous ferment and uncertainty in terms of evolutionary mechanisms. They're concerned about pointing out their pet theory and their opponent's pet theory in precisely the right light, and they tend not to have their eyes on the ball. And
So again, it's like being too in the weeds about something. So like if, I don't know, part of that is like, don't debate creationists, because, as the old phrase goes, it's like wrestling with a pig, you know? You're both going to get dirty, but the pig likes it. Pig wants to get dirty. That's the whole point. If a young Earth creationist, somebody who's trying to say, oh yeah, all of, you know, organisms on Earth were all poofed into existence 6,000 years ago, you know, completely disregard the fossil record, DNA evidence, evolutionary biology, all of this stuff. If they're saying that, and they get to be on stage, shoulder to shoulder, not shoulder to shoulder, but, you know, both of their different podiums, on the same level, the same stage, as somebody who actually has devoted their life to studying the evolution of life on Earth, that's a lot of clout that they're getting absolutely for free. And you've already lost at that point. Already lost the battle. Because to the audience, everyone can see, oh, well, these ideas, they're, you know, there must be equal likelihood that they're true, I guess, if these are people on the same stage and they're going to seriously argue about this. You know, it's like having a a professional cartographer, somebody who, studies maps and map making, and they've done this for, decades and decades, and then they get up on stage to argue with a flat earther. Someone who basically doesn't believe in the idea of geography. It's like, you're kind of giving the fringe idea way too much credence by even letting it be on the same stage, That's part of it. But part of it also is that the cartographer very well might lose that debate because they haven't heard all of these bonkers, like, internet conspiracy ideas that's just the water that this conspiracy theorist flat earther swims in. Like, that's the air that they breathe. And so they can just throw forth a bunch of talking points that might be complete nonsense, but they take way longer to debunk than they take to say. There's this idea, what was it? Brandolini's law, also known as the BS asymmetry principle. Internet adage coined in 2013 by Alberto Brandolini, Italian programmer, all states, the amount of energy needed to refute nonsense is an order of magnitude bigger than the need to produce it. Another way of saying this is like, a lie can make its way halfway around the world while the truth is still getting its pants on. And Gish galloping, which is a technique made famous by Duane Gish, which is where some of these ideas in the creationist video actually came from. Yeah. Duane T. Gish, he's the guy who, he's essentially the father of, like, modern young earth creationism. Sorry, thought I had his book here, but it's a different one. Yeah. Duane Gish is he walked so that people like Ken Ham could run. People like Gish realized that, like, you could just throw out a bunch of nonsense and it takes way longer to debunk, to tell the actual facts than just to say the nonsense. And so you could completely tie up debate opponents in this by just, throw it all out there and let them deal with it. And while they're still dealing with it, they run out of time, and then he could say a bunch more nonsense. And as long as you're a charismatic speaker and you don't actually care about what's true or what's not, you can 1,000,000% win a debate in front of an audience because you appear more confident. You seem like you know what you're talking about. You're more well rehearsed. You could be funnier, more charming because it doesn't actually care to you. It doesn't actually matter to you. You don't care about what's true and what's not. You're just putting on a show, So that's something that Ken Miller understood in his advice, trying to tell people, like, hey, if you absolutely have to have a public debate with a young earth creationist, here's some advice for you. Here's some things to avoid. That kind of thing.
What I mean by that is that the ball in this case is not evolutionary mechanisms. The ball is natural history. What was the past of this planet like? Now, on that question, evolutionary biologists have had it answered for so long that quite literally they no longer pay attention to it. And that is, the past shows descent with modification, change through time. And if you make that case and you make it carefully and with respect for your audience, you'll win the day. You'll make some good scientific points, and you'll have a great time. Thanks.
Anyway, I'll give you a link to this video right here. Yeah. There we go. Let me catch up to chat here. Yeah. Flat earthers can be proven wrong. All they have to do is take a flight to Australia, says Pfizer. No, that's the thing, is that they can't be proven wrong. It's literally impossible to prove to a flat earther that they are incorrect because they didn't arrive at their conclusions through logical means. So you can't use logical means to show them that they're wrong. They believe what they believe because they want to believe it, not because they've actually become convinced of it in a logical way. Like, I don't think you could do that. You know what I mean? Like, there was a thing where somebody raised funds to send a bunch of flat earthers to Antarctica to show them that, hey, it isn't a giant ice wall around the perimeter of a flat earth. Like, it's a continent at, you know, the south side of our planet. And I don't know the full details, but from what I've heard, basically the flat earthers like, yeah, we still don't buy it. Maybe we're a little confused, but the Earth is definitely flat. It doesn't matter. They're just going to move the goalposts. And this is true with a lot of different things. With flat earthers, with young Earth creationists, with anti-vaxxers or Holocaust deniers or whoever else. The thing is, they don't actually care about what's true. They've got their minds made up, and unless they're really, really going to be fair-minded, and it is, some people do change their minds. In some ways, I was raised to believe that, that evolution is a lie of Satan meant to, to mislead people and send them to hell. Like, I had teachers and pastors and people who told me that growing up. And I was able to get out of that because, on some level, I actually cared about what was true. It's often uncomfortable, even scary, to follow the evidence where it leads, because it might mean that some of the things that you've been taught since you were a child are 100% false. It takes courage to follow the evidence where it leads. But that's the essence of science. It's trying to figure out what's true, no matter what it might portend for your closely held personal beliefs. If you want your personal beliefs to conform to reality, rather than having reality get squished and torn and deformed to fit into your personal beliefs, well then that's, maybe you could do science. That makes sense? Yeah. Let me scroll down here. Jim says bird flu could be very bad. Yeah, I agree, Jim. Yeah. And Muhammad Nafi says the odds of human existence as we know it occurring by pure coincidence. That's not what coincidence means, Muhammad, but yeah, astronomically low. Emergence of complex molecules, evolutionary steps leading to intelligent life. Is it so silly to say that there is an intelligent creator? I mean, there could be, but we couldn't test for it. It wouldn't be a scientific idea. What are your thoughts on this? I'm new to your stream, so I don't know your name. My name is Danny Anduza. I work on dinosaurs. I'm a dinosaur paleontologist. I know we're talking about whales today, but, well, we're supposed to be talking about whales today. But yeah, here, talking about Ken Miller like we were earlier, let me find a clip for you of him talking about this. He is a devout Roman Catholic and an evolutionary biologist. And that's the thing, is that you can't, the way that he puts it, if you start bringing the supernatural into science, you wreck science. It doesn't work anymore. And the same way that, like, if you're trying to fix a car that's not working, and you go, well, shoot, why won't it start? Maybe it's, I've got a bad alternator, maybe there's something wrong with the starter, maybe my fusible link has been severed or something like that, or maybe there's a demon in there, and I need to get an exorcist to take it out. Like, no, you can't introduce the supernatural into something like that where you're actually trying to solve the problem. Because then it could be anything. You're opening the floodgates to anything. As opposed to what we can see and test and fix. You know what I mean? So Let me find this clip with Ken Miller talking about this.
So,
here we go. I'll search in the transcript and I'll find it for you. Here we go. So this is like a dramatic reenact. They couldn't have cameras in the courtroom, so they have to have like a reenactment here. This is a big trial, the Kitzmiller versus Dover trial back in 2005. This is like the big intelligent design creationism trial, where it became increasingly obvious that like you can't teach creationism in public schools. Intelligent design is not a scientific principle. And anyway, I'm just trying to set up the clip here, so take a look.
Stood up to all this scrutiny. What about intelligent design? Does it play by the same rules?
If you invoke a non-natural cause, a spirit force or something like that in your research, I have no way to test it.
So, supernatural causation is not considered part of science?
Yeah. I hesitate to beg the patience of the court with this, but being a Boston Red Sox fan, I can't resist it. Yeah, one might say, for example, that the reason the Boston Red Sox were able to come back from 3 games down against the New York Yankees was because God was tired of George Steinbrenner and wanted the Red Sox to win. In my part of the country, you'd be surprised how many people think that's a perfectly reasonable explanation for what happened last year. And you know what? It could be true. But it certainly wouldn't be science. It's not scientific. And it's certainly not something we can test.
Yep. So that's the thing, is that science is all about testability. That's what sets science apart from other ways of knowing. Is that in science, we run experiments, we make observations, we observe the natural world, we're testing ideas. It becomes impossible to test anything if you throw that idea of what we call methodological naturalism, if you throw that out the window and say, well, you know, it could be that this substance froze because the temperature got too low, or it could be because magical elves came and used their laser eyes on it to freeze it. And these elves are invisible, and you can't test for them. They're supernatural, you know? Don't question it. It's just... I'm not trying to be, like, condescending or anything here, but just when we're talking about, like, supernatural things, they don't belong in science. You cannot test for them. Once you introduce supernatural elements, it is no longer science. Does that make sense? So if we're talking about, like, some all-powerful supernatural creator force or something, sure, that could be real. But the thing is, you can't test for that. Because you could always say, oh, well, the supernatural creator force changed the results of our experiment to hide her identity or something. It's again, going back to, like, logical fallacies and stuff, it's what you'd call a special pleading sort of a deal. Yeah.
The fundamental problem with intelligent design is that you can't use it to explain the natural world. It's essentially a negative argument. It says evolution doesn't work, therefore the designer did it. Evolution doesn't work, therefore we win by default. But when you ask them, what does intelligent design tell you about nature? Does it tell you what the designer did? Does it tell you what the designer used to design something with? Does it tell you what purpose the designer had for designing something? Does it tell you when the designer did it? Why the designer did it? It doesn't tell you anything like that.
Yep.
Basically, it's a negative argument, and you can't build a science on a negative argument.
Yep.
After 3 weeks of testimony on the nature of science, the evidence for evolution, and the failings of intelligent design, the plaintiffs had presented their case.
To watch the whole thing, you got an...
Anyway, yeah, I'll give you a link to this this documentary here. Hopefully the timing will work out. We'll watch this on the anniversary of the start of the trial. Again, this year. I was at TwitchCon last year at the end of September, so didn't quite work out. But yeah. Yeah. Anyway, it is good stuff, Heiser. Yeah. So anyway, I guess maybe we'll go back to this for a little bit, but I think I might get fed up pretty quickly. This like creationist video about how, whale evolution, you know, the fossil record doesn't actually tell us anything. Like, there's a lot of misrepresentation here.
What? Doesn't make any sense. Back to the chronologically ordered series of...
But yeah, and Muhammad says, I don't believe in the 6,000 years thing. Good. Excellent. Yeah. We're on the same page then. Yeah. Yeah. Let's see. Oh, and Muhammad, so you follow Islam. It's actually a really cool thing that, like, so many of the important fossils that show us the evolution of whales come from Pakistan. And they were excavated and studied by devout Muslims. Just because somebody has got, you know, a dearly held, powerful religious faith doesn't mean that they have to be opposed to science. People like Ken Miller show that look, if your faith preaches that the truth is a good thing and that we should pursue it, that's what science is, you know? There shouldn't be any conflict there. There absolutely doesn't have to be any conflict, you know? And you're Pakistani. Yeah, excellent. Here, let me see if I can find you a video on Pachycetus, because, again, our theme today is we're talking about the evolution of whales, and Pakistan is probably the best place in the world for studying the early evolution of whales, their origins. Let's see here. I'm trying to find you a decent video on this. Let's look at this, maybe. Oh, and hang on, this is longer than I thought. Here, Pachycetus here.
A team member cracks open a rock.
There we go.
The Suleiman Mountain Range.
In Pakistan. The stream is so fun. I was tired of the video game streams, just mind-numbing gameplay. Mom, thank you for the kind words. I appreciate you. Thank you.
Once the bed of the ancient Tethys Sea.
Beautiful country here.
Locked away in this rock are secrets of ancient marine life and death.
Oh boy. So dramatic.
In 1978, a team of fossil hunters from Michigan set to work.
And some people, obviously, from Pakistan as well. It does bug me sometimes when these documentaries just focus on the Americans going abroad and making these discoveries. It's like, there are people from that country who lived nearby who helped with this, made really important contributions. Why don't you show them on camera? You know? But that's American media for you, sometimes.
Paleontologists are time travelers. They visit the ancient past by digging into the earth. Each layer of rock is like a time capsule, recording major events in the planet's history. Asteroids, natural disasters.
Yep. It's kind of a basic explanation of stratigraphy here. It's most basic.
It's all recorded in layers of rock, planet Earth's DNA. team member cracks open a rock. Inside is a fossil, unlike anything they've seen before. This fossil sets one man on a voyage of discovery. The expedition leader was Philip Gingrich.
Yeah, Phil Gingrich. It's showed up multiple times
of Michigan vaults.
in today's stream.
He examines his amazing find. It's the partial skull of a mammal that lived 50 million years ago. In 1978, Gingrich couldn't work out which family of animals it belonged to.
When we found it...
So it's the sagittal crest, midline, back of the animal skull there.
I really wasn't sure what it is. I was a specialist of land mammals.
So dramatic.
And it didn't look like anything I knew.
Gingrich commissioned experts in mammal anatomy to reconstruct its skull.
So they had other pieces of it too. It's not just, oh, let's see what the skull looks like based on this one fragment. They had other specimens also.
Gives you an idea of what the whole skull might have looked like. This is real and this is reconstructed, but it's reconstructed following the plan of a typical mammal.
And Muhammad studying physics right now. Oh, very cool. Well, I'll be ending the stream before too long, so you can get back to physics, or feel free to tune in whenever you want. I stream 4 days a week, Monday, Tuesday, Wednesday, Thursday. Unless I'm in the field digging up fossils, then I stream 7 days a week. But, yeah, really cool that you're studying physics. It's good to have you here, Muhammad. You should be proud that some of the most important vertebrate fossils found in the last 100 years have been found in Pakistan, including Pachyscetus here. Cleaning the fossil here. Again, it's so dramatic.
Uncover more
this is exhausting.
Pieces of the skeletal jigsaw. Finally, this enigmatic animal comes to life.
Really spectacular. Thank you, Mark Melvin, for gifting
Mark
Muhammad.
Melbourne gifted a tier 1 sub to Muhammad Nafi. They have given
appreciate that, Mark.
201
Thank you,
gift
thank
subs in the channel.
Good stuff. Good stuff.
I think it would have 4 limbs. I expect probably it had short hair. And they still have hooves. If we think it's a land animal, we'd expect it to look wolf-like.
So I think we've got more or less.
But Gingrich still couldn't
majority of the
identify
skeleton
which
of
order
this
of animals it belongs to. Then he spots a tiny, S-shaped bone in the ear region.
Yeah.
He finds out that this bone is known as a sigmoid process, and it's unique to one order of animals that today lives in the water.
Yep.
Gingrich finally realized what this creature is.
It's a whale.
It's something primitive, it's something transitional, but nonetheless, with the
Ancestral
sigmoid
whale.
process, a primitive whale.
Yeah. So again, that's what we're
This
talking
can
about
only mean one thing. The modern whale began life as a land animal.
here. Yep. In Pakistan.
To find out how a land animal evolved into the modern whale, we must return to ancient Pakistan.
And thank you, Red Zed. I appreciate those 26 months of support. Thank you so much for the Prime there, Red Zed. Thank you.
Ontogeny.
Every
Good
day is Ontogeny
stuff.
Day.
Appreciate that, Red.
This is the ground the creature walked on 50 million years ago.
You really have had those spires
The
like
world
that?
then is a hotter place.
Anyway, I'll give you a link to this if you'd like to watch the rest of it. But, yeah. Yeah. So again, here's that critter. Pachycetus here.
Link.
Third, it may not seem like much. 500 bits goes a long way towards supporting science. Our tweet here on Twitch.
Thank you, Miss Caprical, for the 500 bits. I appreciate that very much. Thank you.
Then, in 1989, in a remote desert in Egypt,
Yeah, Buddy Hawk.
Philip
I know, it
Gingrich
does
of the
feel like
University of
CSI,
Michigan
doesn't it?
discovered another Basilosaurus fossil. This Basilosaurus had legs. The legs were beautifully formed, but they were no to Indonesia. But continental drift was rearranging the Earth's surface. India, then a separate landmass, was colliding with Asia, pushing up the Himalayas and emptying the Sea of Tethys.
As India moved north, the sea became shallow, and that shallow sea became saline, and the high salinity and the exposure to sunlight made it highly productive. Now, plankton eat the nutrients in the water, fish eat the plankton, and the importance for whale evolution, I think, is that there was a big fish resource there waiting to be exploited.
So the idea is that, like, you know, lots of resources for these animals to exploit, which is why it was a good place for whales to first evolve, and that's why it makes sense that it happened here. It's this area, ancient Pakistan, about 40, 50 million years ago, thereabouts. It was the perfect place for big vertebrate animals to move from the land back into the ocean and be able to make a living.
But the new whale, called Indocetus, was still more at home on land than in the sea. Unlike modern whales, it had tailbones that were fused together, giving it added strength to support its weight on land. Likewise, its well-developed hind legs showed that Indocetus was still primarily a land mammal. Once again, the missing link had eluded paleontologists. What they needed was an animal that could both walk and swim. On the ancient shores of Tethys, the fossil record would not disappoint them. The most finely forged link in the whale evolutionary chain emerged in 1994. Like his colleague Philip Gingrich, anatomist Hans Thewissen also made the long trek to Pakistan in search of ancient whales.
Yep.
In sediments almost 400 feet above the beds that yielded Pachycetus, Thewissen and his associates collected the remarkable skeleton of a new whale. In his lab at Northeastern Ohio University College of Medicine, Thewissen assembled the skeleton and realized he had found the evolutionary Holy Grail, a relatively complete fossil of the elusive, the impossible, the always derided missing link.
Missing link.
He called it Ambulocetus natans, the walking, swimming whale.
The most important single aspect of Ambulocetus is that it documents very well the shape and the size of the limbs, the forelimbs and the hind limbs. This specimen is more complete than any other primitive whale, and it shows us therefore something about how these animals swim, how they use those limbs in the water and on land.
Thank you, Hogan, for the 100 bits. Thank you, thank you.
Ambulocetus's complete limbs prove that it was the missing link. The enormous hind feet held close.
The missing link. I mean, there's so many links in this, you know, grand story that this isn't. I don't know. It bugs me when TV writers are too simplistic about these things. Because there's so many links in that whole chain. Any one of them could be missing. Yeah, and the more links you find, the more end up being missing because once you fill in a gap by finding a missing link, well, suddenly you've got 2 new gaps on either side of it. You've created 2 new missing links by finding the first one. So,
Most of the body were clearly adapted for swimming, yet were also capable of supporting the animal's weight on land.
If you think, for instance, of recent seals or sea lions, those are animals that spend most of their time in the water, but they come back to land to do copulation, to give birth, to suckle their young. But pretty much everything else is done in the water, and probably whales went through a stage like that.
Though Ambulocetus was a stunning discovery showing a critical step in the evolution from Masonachid to Basilosaurus, the remarkable parade of fossil evidence was not yet over. For Ambulocetus was an animal that swam with its feet, like seals. When did whales evolve into creatures that swam primarily with the use of their tails?
yeah, and it's a good question. Yeah. We've been streaming for 5¼ hours at this point, and I've got some stuff I got to get done tonight. So I think I'm going to start to wrap this up. I hope this has whet your appetite just a little bit. I'm getting hungry. I think dinner soon. I hope this is build a little bit of appetite for you to maybe learn a little bit more about the evolution of whales, because it is incredibly fascinating stuff. And it's something I don't know a great deal about myself. Again, I don't work on whales. I work on dinosaurs. But I know just enough to recognize how cool a story this is. Learning about the evolution of this group, their transition from life on land to life in the water. Whales are some of the most remarkable of the living mammal groups in a lot of ways, and the story of their evolution is... it's so cool, and it's a story that's becoming clearer and clearer with every passing year. New fossil discoveries, new techniques of studying them, new and better questions being asked about whale evolution, because the more we learn, the better we get at asking these questions. So yeah, happy World Whale Day to everybody. Thanks for being here while we talked about fossil whales and whale evolution and everything along with that. Talked about today. Right now, let's there, put a Smilodon under our credits today in honor of mammals. We're gonna find somebody to rate into. Maybe somebody else doing some science right now. Who have we got? Let's see here. Science Streams is on. Let's go raid into Balint and see what he's up to. He just got a raid. We're gonna go exacerbate that. Thank you to everybody who's showing up here in our credits. Everybody being named here. Subscribers, resubscribers, cheerers, gifters, followers, raiders, moderators. Thank you all for your support, your attention, your enthusiasm, all that good stuff. We'll be back to dinosaurs tomorrow, talking about some dinosaur news, new publications. We've got some cool new dinosaur papers to discuss, and I hope you'll join me for that. Till then, everybody, you take care of yourselves. Thank you again. And let's go see what Balint is up to over at Science Streams. By the way, Balint is another active research scientist. He's a molecular and systems biologist, and he's eager to answer whatever science questions you might have. So, don't be shy with those questions. Anyway, let's go check in with him.